You're listening to the Common Descent Podcast.
Hello, Will.
Hello, David.
Hello, everybody, and welcome to Common Descent, a podcast where we talk about paleontology, evolution, the history of life on Earth. This is episode 225. This episode number ends in a 5, which means we're talking about plants, which means that after the news, we will be joined by our favorite paleobotanist, Dr. Aly Baumgartner, to talk with us about this episode's topic, forests.
Yeah.
I love talking about a biome. We will talk about what forests are, how they function as a biome, as a home to ecosystems, how we study them in the fossil record, and how what forests are have changed throughout the history of plants on Earth.
Yeah, this is a fun one because I know what a forest is, but I know I don't know what a forest is.
Yes, exactly. We're excited. Aly's excited. And you know who else is excited? Probably all these people who requested this topic. Every episode of the podcast is a topic requested by our listeners. This episode topic was requested by Sam, Serpentine, Jackie, Apricity, Skull, Artist on a Mountain, Big Boss Man, Peter, Ryan, and Joe.
Good suggestion, everyone.
Thank you all. Stay tuned for that Forests deep dive after the news, which is after these announcements. First and foremost, we have a Patreon. The support that we receive on Patreon allows us to do all the cool, fun stuff that we do on the podcast, including things like make donations to support reptile conservation, like we do at the end of Croc and Snake Month, which just ended a little bit ago.
Yeah.
Patrons on our Patreon get all sorts of goodies like live streams and bonus content and merch. And at certain levels, you get your name shouted out on the podcast. This episode, we would like to welcome new patrons, Felix, Etienne, and Nathan.
Welcome, welcome, welcome.
But wait, there's more. So we have a new feature on our Patreon where you can gift somebody else a subscription. You can make someone else a patron of ours as a gift. And as it turns out, because gifted patrons are categorized differently on the Patreon back end, we've missed some people who should have gotten a shout out earlier this year because we didn't see it in the normal list where we look. So, an additional welcome and our sincerest apologies for being late to Claire, Dan, Cabbage Boy, and Bogdraw.
Yes, welcome, welcome. Hope you enjoy your gift.
Thank you all so much for your support. If you would like to support us on Patreon or gift a patronage to somebody else, check out the links in the episode description. Other stuff that's going on, our spin-off podcast, Leave It to Us, is quickly approaching the end of their first season of the show. Very excited. We've got tons of great interactions and engagement with the audience. Season 1 is going to end with a mailbag episode. So if you are a patron supporting Leave It to Us, you can submit questions for the mailbag episode. Speaking of mail, we recently received a book, a physical in-person book from our listener, David. Will, what's that book like?
It's neat. It's Dinosaurs of Africa and has some really great art and a lot of cool dinosaurs in it. And it's a nice classic illustrated dinosaur book, like just one of those classic ones I would have gone for as a kid, and it's just one of those great examples of a dinosaur book.
Very cool. Thank you very much to David for sending us that book. And finally, 2 more announcements about 2 upcoming, very exciting events. First, our next museum meetup will be taking place at the Fernbank Museum in Atlanta, Georgia on Saturday, October 18th at 1 p.m. Both me and Will be at the museum. If you're in the area, come say hi. We'll explore the exhibits and hang out together.
Yes, I'm so excited. It's going to be a ton of fun.
And speaking of October, this episode comes out right at the border between August and September, which means October is right around the corner. And of course, every year, October is when we do Spook-E. Spookulative Evolution is our series where we choose monsters from fiction and popular media and discuss how those creatures or something like them might evolve through the real world processes of natural selection and evolution. Every year we have a theme. We did plant monsters, we did sea monsters, we did monsters of Dungeons and Dragons. Last year we did tiny monsters. It is now time to reveal the theme for Spooky 2025. This year, we will be evolving Monsters of Nintendo.
Ba-da-ba-ba-da-ba.
I'm so excited to put these episodes out. They're recorded. We had tons of fun putting
There's some
these
good
together.
ones.
It's awesome. Stay tuned. Spooky episodes come out every Saturday in the month of October, plus a bonus Cute E episode, and then a spooky live stream.
Yes.
Stay tuned. Join the discussions on the Discord. Follow us on the social medias for updates and chit chat with your fellow spooky fans. That's a bunch of announcements. Let's move on to the news. Every episode, we like to start out by discussing some of recent science news in the fields that interest us. Will, what news brought you to the what do you got?
Today, I have some news on bioturbation and how it's changed over the years, which is sea sediments and sometimes land, but mostly sea sediments getting mixed up by animals. This is research by Lydia Tarin et al. In Science Advances, and the article is by Jim Shelton, a press release from phys.org. So, bioturbation, we've discussed before because of the Mesozoic Marine Revolution episode. This is a phenomena of organisms mixing up and burrowing into the sediment. So, turbation is the mixing of sediment, bioturbation is it happening by animals.
Yes.
This is a well-known phenomena in today's oceans. It also happens in terrestrial environments, but it is famous and very critical to marine ecosystems. It's I saw it listed as one of the most important forms of ecosystem engineering in today's environments.
Yes. Yeah, when you hear that like earthworms are super important for soils, this is part of why, because they're churning up and disturbing the sediment.
Yeah, they're mixing up the nutrients in the sediment, they're aerating it. In the ocean, it's also really critical for re-releasing nutrients into the greater oceanic ecosystem. There are two notable layers of bioturbation. There is the upper, more homogeneous mixed layer, which is the portion that's getting just churned up by different animals moving through it, and then an underlying transition layer, which is burrows. These two are easily measured today, but we don't have a great understanding of how that dynamic came to be the way it is throughout history. So, this is research trying to map out the history of bioturbation on our planet in more detail. They collected data from fieldwork in the US, Canada, Spain, and Australia, sediment drill cores collected from around different oceans, and they surveyed more than 1,000 previous studies to try to put together a map of how bioturbation has formed and changed and come to be the way it is today throughout the Phanerozoic. So their data goes back over 540 million years of Earth history. So basically, all of animal history. So the entire time there could be bioturbators, effectively.
Yes, the whole history of bioturbating.
Yes. They focused in on 6 specific fossil burrows, types of fossil burrows that are typically among the deepest known in the seafloor. And through all of this, they found a really interesting pattern that those two layers, those two types of bioturbation of burrowing and sediment mixing happened at different times and rates. So deep burrows formed early in animal evolution, sometime in the Cambrian.
Sure, that makes sense because we've talked about that being part of the Cambrian substrate revolution, the development of modern seafloors.
Exactly. So that deep transition layer formed in the Cambrian, but didn't deepen until the Mesozoic.
Oh.
So it formed, kind of stayed the way it was for a really long time, deepened, and then was more like it we see it today. Sediment mixing, which is that upper layer that's more homogeneous, took hundreds of millions of years to slowly increase and deepen. And so these two different kinds of bioturbation happened at different phases and speeds and had very different patterns.
Interesting.
The burrowing stuff did show a pattern of starting in shallow oceans with things like worms and later clams and crustaceans, and took longer to get into deeper oceans.
Okay.
So we do see a pattern there. The sediment mixing had a much more lagged pattern. They think that it's likely things like ocean oxygen stress may have been a major driver. So during particularly warm periods where oxygen levels were way out of whack, this could have had an effect on sediment mixing because under warmer waters, metabolism rates are going to be higher, so they're going to need more oxygen. So if oxygen levels are not ideal, that may have favored the burrowing, which is a less energy intensive behavior than sediment mixing.
Oh, okay.
And so it may have been that burrowing caught on sooner because of energy requirements, and sediment mixing took longer to catch on because it was a more energy intensive activity by comparison. They were also able to note that it does seem there are patterns with major environmental changes and extinction events. One that they noted was during the end Permian mass extinction, which is one of the big ones where 90% of life died out. Bioturbation seems to have ceased for a time.
Sure.
Yep. And then small horizontal burrows slowly began to come back.
I like it. In my mind, I'm imagining that it was just like the Cambrian just had to happen again.
Yeah.
They just had to figure it out again.
And so they said hopefully future research will explore how this pause in bioturbation might have affected the wider ocean ecosystem.
This is one of those topics that really drives home one of the things that I find most fascinating about exploring ancient ecosystems, which is that at different times in Earth history, ecosystems functioned in ways that were fundamentally different than
Yes.
what they do today. Like today, we don't really think about it in all that much depth, but the ocean floor has a very nuanced and complex relationship with what's above it and what's below it and all the creatures that are living in and on top of it. And the way that the seafloor worked has been different at different times, which means that like some of the kinds of ecosystems or ocean animals that we have in that we're familiar with today could not have existed at
Yes.
various times, not because the ocean chemistry or the temperature was wrong or anything like that, just because the sea floor didn't work the right way.
It's kind of like how ancient human cultures all had economies, but many of them were very different to our own. And it's easy to forget that it's like, well, yeah, they had money, we have money, same thing. It's like, well, yeah, they had dirt bugs, we have dirt bugs, same things. Well,
Right.
no.
Yeah. Very cool stuff.
Ugh.
Hey, speaking of the evolutionary history of marine animals, I've got some news about penguins.
Excellent. I saw someone on our Discord point out that they are marine reptiles, which makes me scared to build them in Lego now.
They're marine arcus. Yeah, don't. You gotta watch out. Don't. They can't show up in Bricks with Basque.
Yep.
Penguins, episode 108.
Yep, when 108 comes up, I'm just going to have to skip it.
Just gonna have to skip it. No more marine reptiles. This is research by Gerald Mayer et al. In the Zoological Journal of the Linnaean Society. We will link in the blog post to an article on the conversation written by two of the authors, Vanessa De Pietri and Paul Schofield. Penguins showed up way early on in the Cenozoic era, almost right after the extinction of the dinosaurs at the end of the Cretaceous. The other dinosaur, penguins are still in there. There are plenty of species known of early penguins and penguin ancestors from the Eocene epoch, especially in Antarctica, but not very many from earlier than that. That first 10 million years or so of the Cenozoic, only like fragments and bits and pieces are known for the most part. This paper describes a new assemblage of early penguins from the Paleocene of New Zealand. These penguins are from the Waipara Greensand, which is a locality an hour north of Christchurch on the South Island of New Zealand. They're from the middle towards the end of the Paleocene, 62.5 to 58 million years ago. This paper does not just describe a couple more penguin fossils. They describe a whole assemblage from this geologic deposit, which includes 4 new genera and species.
Whoa!
These are, because names are fun, Daniodiptes primavis, Waiparadiptes gracilatarsus, Archaeodiptes, Waitahorum, and Waimanutaha kenlevi.
Cool.
And on top of those, new material of species that have already been known, including the first skull of the species Muriwaimanu tuatahi. This not only provides new information on the diversity of penguins, including some species that we already knew about, but it brings the total count of early penguin species at this locality up to at least 10 different species.
That's so awesome.
These species range in size from little, similar to the smallest penguins today, to emperor penguin sized, a meter and a half tall or more. And they provide brand new insights into the earliest evolution of the penguin lineage. The fact that there are so many of them just a few million years after the end Cretaceous extinction suggests that this lineage of birds evolved rapidly, radiated rapidly, likely due to the absence of both large land predators and large marine reptiles, which had gone extinct during the end Cretaceous.
I've been thinking that joke the whole time of mosasaurs went extinct and the penguins went, oh, finally.
Yeah, this is our time. Absolutely. These early penguins had specific adaptations. The authors point out that not all of the body became penguin-like at the same time. Some of the earliest adaptations included modifications to the wings, the shoulders, and the feet, which are all involved in swimming, in propelling themselves through the water. These early penguins likely had a more flexible wing. So modern penguins have a very stiff flipper. Early penguins seem to have had more flexibility. They might have been moving their arms, and I'm not pulling this from the paper, this is just me, maybe more like a flying bird with more of that flexibility, whereas penguins today are a little more specialized in that regard. But these early penguins retained these very long, sharp beaks, which is something we don't see in modern penguins, which is probably related to their hunting style. The authors describe that these early penguins might have been more spearing fish than chasing after them, like modern penguins do. They might have been more like a heron. They were jabbing at fish rather than chasing them actively through the water.
Which is also very cool.
Yeah! They point out that the long beaks stuck around for more than 20 million years. Wow. So for a long time, that was just what penguins were like.
Which makes it all the more weird that we don't have any like that today.
Yeah, probably blame whales and sea lions and stuff. Mammals started coming in.
Usually a safe bet to blame the mammals.
Also, and I didn't read any deeper into the discussion about this, but not only, in addition to new species and new material, this paper also describes the first ever gastroliths known from early penguins. So gastroliths are stomach stones, which a lot of birds swallow stones to help with digestion, but marine animals, in some cases, are also using their stomach stones to change or assist with buoyancy as they're moving through the water. All very cool. Altogether, this supports the idea not only that penguins early in that lineage's evolution diversified quickly, but that New Zealand and or the surrounding parts of the world might have been a center of that evolutionary radiation.
So cool.
It's penguins are one of those few examples where I'm constantly shocked at how good a fossil record we have of penguins. It doesn't seem like we should have a good fossil record of penguins.
That's exactly what I was about to say. It is surprising in two regards to me because A, penguins are an unusual animal today. Like,
Hmm.
they're a very strange version of a bird. They live, many of them, in very extreme environments,
Yep. There are also not that many of them
and they're
overall.
fairly rare. Like, there are big populations of many species, and they are found in a wide variety of places. But in many of those places, there's like one or two species.
Hmm.
Like, you don't have like five different kinds of penguins all overlapping most times. So they are a very unique case of animal on the planet today. So, A, not a group that you would typically expect to have a rich, robust, and thriving fossil record, or that they've been around about as long as they could have been around.
Yeah. This is one of the first groups of modern birds that
Yes,
became somewhat like we know them.
that, like, both of those don't feel like they should be the case for a group that's the bird equivalent of like an anteater,
Yes.
like a very unusual specialized animal that doesn't look like anything else it's related to, but
Listen,
yet,
marine reptile apparently is
yeah,
a winning strategy.
it's I mean, it's why I can't avoid them. They work.
Apparently, we've done 1,000 episodes about them.
Woo. Well, my next news is not about birds, but it is about an island group, which feels kind of in line. This is about island foxes, modern island foxes, that seem to be, quote unquote, ignoring the island syndrome rules a little bit.
Hmm.
This is research by Kimberly Schoenberger et al. In PLOS One, and the article is another press release from phys.org. So, the island syndrome is something we've talked about. We focused on the island dwarfism aspects of it.
We talked about this in episode 4 and also in episode 144.
Yes. Island syndrome is a suite of traits that we tend to see in island animals that is things that tend to happen due to an animal being isolated on an island. This includes that we tend to see a change in size, usually that they get smaller, though there are gigantism examples, but they also tend to show more benign behavior, less skittish, more tamer, I saw it described in the article. Loss of flight in birds falls under this description, and typically a shrinking of brain size
Yeah.
that tends to go along with it. These are usually considered to go along with isolation. They're genetically isolated, so they are going to change in a different way than the main population that they descended from on the mainland, but also due to the typically lack of predators, reduced competition usually, maybe reduced amount of things to eat, so a change in their behavior. All of these things might also would contribute to smaller sizes due to less resources, not needing to be as skittish, which could lead to the tamer and brain size not having to be as scared or competitive. The brain size has also been linked potentially to save energy, that it could also be a way to reduce your energy usage on a limited resource environment. Most studies on this have looked at, like, especially the brain size, have looked at fossil species of herbivores. Carnivores haven't been looked at as much. This study wanted to bridge that gap a bit and looked at the Channel Island foxes, which are a number of subspecies of fox on these islands off the coast of California here in the US. There are 8 islands total, 6 of which are home to subspecies of fox that are typically no bigger than a house cat.
Aw, cute little foxes.
Very small little foxes. These foxes, according to DNA and carbon dating, likely arrived on the islands about 9,000 years ago. Some via rafting, floating on vegetation. Some may have swam across when sea levels were particularly lower. There is also archaeological evidence that indigenous people brought some foxes to some of the islands like 1,000 years later or so.
Sure. When they were trying, they also had a goose and
Yes,
some
exactly. Yep.
grain, and they had to. Yeah. We've
Yep.
heard the stories.
And this could have been like, they may have been a form of pest control, like house cats,
Sure.
having them around. This study wanted to look at the brain size of these foxes and how it falls under the syndrome, they studied more than 250 skulls from the 6 subspecies and 4 subspecies of gray fox, which is the larger mainland species that is their closest cousin and most likely their ancestor.
Hmm.
They did I liked this the series of things they did to try to get a solid look at the brain size. They did estimated body weights off of skull measurements and then compared those to recorded weights to make sure that they had a accurate way of doing that. They took brain size measurements using the skulls and microbeads and filling the brain case with microbeads, which is
Sure.
a tried and true tested way to get a proxy for the volume of the skull. They then also CT scanned the skulls to get a model of the interior and confirmed the accuracy of the microbead estimate. So, like, they did a lot of redundancy to make sure that their body size and brain size comparisons and measurements were accurate, which I just thought was very cool. They also used the CT scanning to get a look at the ridges and folds of the brain to see how deep the ridges and folds were and how many folds there were. They also use this research to approach the question of, with those foxes brought over by people, were they domesticated?
Mm.
All of this led to the findings that on 5 of the islands, Santa Cruz, Santa Rosa, Santa Catalina, Santa Clemente, and San Miguel, all those foxes had relatively larger brains than their mainland cousins.
Interesting. Okay. Opposite
Yes.
of the expected trend.
Yes, indeed. They also had slightly deeper folds and ridges of their brain, specifically in the areas for motor control and spatial processing, which may be to navigate the rugged terrain of the islands, and on at least 2 of the islands to compete for food and shelter where they share spaces with rivals like spotted skunk.
Mm.
They also noted that, and the note of their movement, the island and gray foxes are the only known canines to climb trees regularly and hunt in very similar ways to like house cats and feral cats. And so the island foxes may be relying more on foraging in trees compared to gray foxes, and that may be part of why their motor functioning is different. The foxes on the island of San Nicolas were an exception in that this is the second smallest island and the most geographically isolated, and those foxes did show a relatively smaller brain size.
Hmm.
Yes. They noted that on this island they also had no predators and there was lower biodiversity and more limited food. So all of this may have led to less of a need for those cognitive skills and a greater need to save energy.
Yeah, that's interesting because even though most of the foxes are breaking what we would expect to be the trend, that pattern does seem to support the hypothesis of why that trend typically exists.
Yes. Yes, exactly. They also found other features of this brain that were interesting. Digital scans revealed that their brains are shorter and have a more compact frontal area. And this is due to their relatively shorter snouts, decreasing the area for the brain at the front, and may also be a reason why there's more folds in that region to compensate for the lack of space that has happened.
Sure.
All in all, this has been interesting because A, it shows that the island syndrome is not a, as they put it, one size fits all.
Hmm.
There are differing situations that can lead to breaking of the trend, and even within the same general group, differing results in the syndrome. It also indicates that reduced body sizes on island may, in instances like this, outweigh the benefits of a smaller brain, so that having a small body effectively gets you what you need so you don't need to reduce the brain, except if you're in a really nutrient reduced area like the San Nicolas Island. And in this case, it does seem that the brain to body ratio was shaped less by isolation and more by island size.
Yeah. Interesting. It would be really interesting to now do the same study with like those spotted skunks
Yes,
or other
absolutely.
carnivorous mammals.
Absolutely. They also note that the disparity in the brain size among the specifically 3 southern islands, and these all have increased in civilization, increased brain size for the foxes, also suggests that humans that brought them there probably had not domesticated them.
Right. Because if I remember correctly, smaller brain size is also associated with domestication. Episode 27.
Exactly. And these do not show any of that trend. They noted that their proportions, brain size, behavior, and body size more closely resembled wild cats than early domestic dogs. So they don't seem to show any signs of true domestication. So these were likely tamed animals, or at least caught animals that were brought in for pest control, but not actually pets.
Very cool stuff.
Yeah.
Well, I've got some new. I actually have two more bits of news. One of them is a little
Cheater.
bonus. The first one is about dragonfly fossils. Or to be more exact, one dragonfly fossil in a place that no one expected it. This is research by Andre Mueller et al. In the Canadian Journal of Earth Sciences, and we'll link in the blog post to a press release on phys.org from McGill University by Claire Lowen. This dragonfly fossil comes from Dinosaur Provincial Park, which is very exciting because, number one, dragonflies have never been found in the fossils of that park before. And number two, I was at this park. Nora and I
Yeah.
were here this past summer. We also did not find any dragonfly fossils.
You were just a step too late.
We were in the wrong place. Actually, this fossil was discovered in 2023 by an undergraduate student during a field course from McGill University. The group were reportedly in an area cracking rocks open to find leaf impressions in a place in the park where leaf impressions were known to be preserved between the sediments. One student cracked open a rock and found a dragonfly wing impression in the sediment, which that's so cool.
That's one of the more exciting things you could possibly find.
Absolutely. This fossil comes from the Dinosaur Park Formation, which is late Cretaceous, about 75 million years ago. It is the first ever Mesozoic dragonfly fossil found in Canada. It is one of very few dragonflies known from the late Cretaceous worldwide. So we just don't have a lot of information about late Cretaceous dragonfly evolution. It is the second insect fossil ever found from the Dinosaur Park Formation. The other one was an aphid in amber.
Cool.
So, as the article put it, this doubles our knowledge of insects from the Dinosaur Park Formation.
Yes.
This wing is fairly small. The total wingspan would have been about the size of a human hand. Based on the anatomy of the wing, it seems to belong to an important group called Cavalabiata, which is a major group of dragonflies. Their wing shape tends to be the same shape as we see in modern dragonflies, adapted for gliding, which is commonly seen in migratory species. Based on the features of the wing, we talked about this in the dragonflies episode 181. Dragonfly fossils tend to be described off of the wings. So this one is a new genus and species, Cordualadensa acorni, in a new family, Cordualadensidae. The dragonfly species is named for John Acorn, who is an entomologist at the University of Alberta and formerly had a TV show called Acorn the Nature Nut, which is very cool. This is a really cool discovery. It, again, first dragonfly fossil found from this formation, confirms that insect fossil impressions can be preserved here. So now that's something we could look for in the future. Fills a bit of a gap in our knowledge of dragonfly evolution in the late Cretaceous, and tells us things about the food web of this ancient environment, particularly in the late Cretaceous of Alberta. I didn't mention this earlier. Dinosaur Park, Provincial Park, is in Alberta in Canada. Knowing that there were dragonflies around, which isn't a surprise, but we didn't know that, is really useful because dragonflies occupy a very important part of a food web. They are predators and they're also prey.
That's super cool. Like you said, it's not a surprise at all that we have dragonflies there. It is very cool to get to confirm and get to identify what dragonfly, or at least one of the dragonflies that was there. And, I don't know. Dragonflies are always such a fun fossil to find because they feel like such fossil royalty.
Yeah.
That's like some of our earliest insect fossils, and like especially flying life form fossils, are dragonflies. they've been doing what they've been doing for almost as long as animals have been on land. And that's very cool. So even when we find one that is much more recent or much more just like our modern dragonflies, it's still very much like, yeah, there you are. There you are.
Yeah.
I knew you had to be somewhere, and you showed up. That's so cool.
And I've got one more bit of news, just a little brief note. News from the Gray Fossil Site, our favorite fossil site here in East Tennessee. A paper just recently came out describing the first confirmed deer fossils from the fossil site. The Gray Fossil Site has lots of perissodactyls, so odd-toed ungulates. There's tons of tapirs, there's tons of rhinos, and there's horse. But artiodactyls, even-toed hoofed animals, there's fairly few. There's a bunch of peccaries, there's some bits of camel, and apparently bits of deer.
Yay.
This includes some jaw bits, at least one tooth, some limb bones. They are true deer, Cervidae. So the same family as our modern deer. They identified it to the species Eocoileus gentriorum, which is also known from similar time periods in Florida. These are among the earliest cervids in North America.
Cool.
And the features of these bones are similar enough to modern deer, like our white-tailed deer and things that we have in North America today, that the authors suspect that they were probably living very similarly, being sort of an all-purpose browser in these forested environments.
And leaping out in front of the mastodon as they're going down a path.
Yes, and then freezing. This is research. This was published in Paleontologia Electronica by Josh Samuels et al. And included in that et al. Are such names as Shay Maiden, who was our guest in episode 198 to talk about eels, because in addition to being a fish person, Shay is also a bit of an artiodactyls person. And Olivia Williams, who is one of the students who's been working in collections and researching at the museum recently. So very cool. Congrats to those authors.
Yeah, absolutely. Get to add a deer to the collection.
Well, speaking of browsing in ancient habitats, forests. That's a great kind of little segue. Let's move out of the news to our main discussion for the episode. After the break, we will be joined by our recurring guest, Dr. Aly Baumgartner, who will regale us with tales of plants and stuff.
Yay.
Stay tuned. Hello, Aly.
Hello, David.
Hello, Aly.
Hi, Will.
Welcome back. Thank you, as always, for joining us.
I'm so excited. Oh my goodness, this is going to be great.
For any listeners that this is your first time encountering Aly on the podcast, this is our friend, Dr. Aly Baumgartner, botanist and paleobotanist extraordinaire, and co-host of the world-famous Leave It to Us podcast.
World famous, it's true.
World famous. People listen to it all over the world, and you can listen to it right now. If you enjoy hearing Aly talk about plants, now there's a whole podcast that is just, the whole podcast is Aly gets to talk about plants.
It's great. I just get to go. It's wonderful.
It's fantastic. You can find that wherever podcasts are sold, and also you can support it on Patreon. Leave It to Us. As of this recording, Leave It to Us is in the second half of season 1, and you can go check it out. It's super great.
We have so many fun episodes that we've already done and that we're going to do. Oh, it's going to be so good.
But today we are not here to just gush about Leave It to Us. We're here because we have a whole topic. We're going to cram in 3 episodes of Leave It to Us worth of discussion time on the subject of forests.
I'll try to keep it only to 3.
Now there's 2 podcasts to do outlets for more further discussion.
This is true. Maybe that'll make it a little bit easier to, stay on target.
Yeah, that's why we made Leave It to Us originally, was to vent the steam a little bit, just relieve pressure.
Because I talked about leaves for 2 hours and change. And that was the short version.
And our fans keep being like, oh, I wish I could listen to Aly talk more. And we're like, not on our podcast. We got animals to talk about.
We need more room for animals.
we got animals to talk about.
Exactly.
This episode is all about forests, which I am very excited about because this is a very cool topic. And I know, Aly, you're excited because you're a nerd.
This is true, specifically about biomes, specifically about forests. And of course, you're gonna like this because you know what's in forests: animals.
Animals.
Animals do live there. That's
It's
true.
yeah.
Those are some of the
Forests
best parts.
is where animals are.
Yeah, it is known.
Let's begin at the beginning, Aly. So obviously forests have trees,
Yes.
but also obviously not everything with trees is a forest, and there's also like woods, and so let's zero in. What defines a forest?
I like starting with the squares and rectangles. So all forests have trees, but not everything with trees is a forest,
Yeah.
as you mentioned. So importantly, the distinction between a forest and other kinds of tree habitats is that forests are closed environments.
Hmm.
Ah, yes. That was the reaction I wanted. So an open environment is one where you can see the sky.
Yeah.
Like that is the does this environment have a ceiling? Yes or no?
Yes. Yep.
That's pretty much it. So a closed environment is by and large going to be a type of forest. Open environments have way more variability. You have your woodlands, which have trees, but fewer of them,
Yeah.
and like grasslands, deserts, things like that. There is not really a single definition of what a forest is. I have strong opinions about what I think the definition should be, but there's not one, because the thing about forests in particular is that this is a biome that humans care a lot about,
Sure.
either for conservation reasons or for logging or for raising for agriculture. There's a lot of reasons why humans think a lot about forests. And so a lot of legal definitions of forests just include everything with a tree.
Yes.
So that means that anything with 10% or more canopy cover is a forest.
Oh, wow.
Right? 10% is very low.
Yeah.
Personally, no, disagree. I'm so sorry. A woodland, a savanna, these are not forests. Nice try. Trees are cool, but that's not enough. So I liked the land cover definition. So that one's much stricter. That requires 60 to 100% canopy cover. So
Nice.
more than half of the sky is covered or has the potential to be covered if you have immature trees.
Yeah.
In addition to this, I'm going to be talking primarily about plants, almost exclusively about trees, but I want to just mention again. So, while forests include and are literally named for the fact that there are trees in it, there's also the flora, other types of plants, the fauna, the funga. I don't know how I feel
Yeah.
about that word, but we're trying it out. And also the soils themselves.
Sure. Forest is, it's easy to look at it and go, yes, trees, then therefore forests. But because of all those trees and because of the conditions that you need in order for all those trees to exist like that, it's an entire ecosystem and environment that is distinctive.
Yes, don't miss the forest for the trees.
Yes.
Aha, there it is. Well, speaking of the forest ecosystem, one of the this is like elementary school science. Going back in my head and looking at diagrams.
Yes.
Forests are also categorized by the structure, which is different from a lot of like a grassland or a desert.
Mm-hmm.
We don't tend to think about grasslands in 3 dimensions.
Correct.
But forests have a 3-dimensional structure to them.
It's my favorite part.
Well, great. Go off.
I argued with a reviewer about this.
I'm sure they had it coming.
I was right, and I stand by it. So when you are talking about forests, as you mentioned, you have both lateral differences, lateral heterogeneity, so horizontal differences, and then also this vertical aspect. And that is absolutely my favorite part of forests. I think it is the most interesting part of forests. And it is also, I think, underappreciated and really hard to get at in the fossil record for I
Sure.
think
Yeah.
obvious reasons, but we'll get into that a little bit more later. So I'm going to actually start at the bottom and go up when I'm talking about the layers. Every diagram, you always start at the top and work down, but no, I'm going to give the soil the attention it loves because the only thing that I like nearly as much as plants is soil. I took a lot of fossil soil classes in my PhD. Anyway, so the actual bottom of a forest is this soil layer, the root layer. And this is actually really important because forests have very distinctive types of soil. So I will be talking about that later, but you can get a good idea of what kind of forest you're looking at just by looking at the soil structure, which is
Yeah.
really, really cool. Then above that, I'm going to be using the European names for these layers because I think they're way more helpful to visualize. So above the root layer, which is the soil, it's below the ground, you have what's called the moss layer. So
Mhm,
that
mhm.
includes like the very top of the topsoil and then goes up to 0.15 meters, which is about 6 inches.
Sure. About the height of moss.
About the
Yes.
height of it's almost like that's why it's called that, right? So this is the very bottom. This is basically the ground, right? And so this is going to include your decomposers, a lot of insects, the mycorrhizal network. That's what's going on in this very narrow band at the bottom. Above that is the herb layer. Again, this is where all your herbaceous things are going to be hanging out. So this is up to about 1.5 meters, so about 5 feet tall. Again, this is going to be your herbaceous things. These are plants that need a little bit of light, but a lot of moisture.
Mhm, mhm.
And same thing with like the moss layer. They don't need a whole lot of light, but they're going to need a lot of moisture because their roots aren't going to be as extensive because in general, you kind of go up as much as you go down. If they're not very tall, they're not going to have very extensive
Mhm.
roots in general. Then you get up into the shrub layer. So this is between 5 feet to about 16.5 feet or 1.5 meters to 5 meters. So these are getting into smaller trees, bigger shrubs. This is the layer that needs sun. So it doesn't need nearly as much moisture, but it needs sun. So this is the layer that's really relying on any sorts of gaps that you're going to have from the trees above them that are really going to thrive in disturbance. And then finally, the layer we all think of when we think of forests is the tree layer. And this can have multiple layers within it of like understory, canopy. So this is basically anything above 5 meters. So anything above like 16.5 feet, everything above that is canopy. And depending on the type of forest, this can have multiple layers within it. So it is the density of the trees that determines the amount of light inside the forest, right? So if you have 60% canopy cover, that's a whole lot more light that's coming down to the forest floor than 100% canopy cover. You have a ceiling at that
Mhm.
point. The other cool thing that the canopy can do for everything below it is basically an umbrella.
Mhm,
Oh,
mhm.
sure.
Right. So it reduces basically the velocity of rainfall and just kind of a perpetual drizzle, which is nice. It doesn't beat up on those little baby plants, right? Not necessarily literal babies, but metaphorical babies.
Mhm,
Um,
mhm.
so it's basically a more even distribution of this moisture. And then finally, you have the emergent layer, and these are any trees that are taller than the rest of the canopy.
Right. Just those occasional
Yes.
ones sticking up out of the
Yes.
rest.
Even taller than all the tall trees. So, if we're thinking vertically, that's basically the layers that we're talking about. When we talk about like multi-storied canopy, that's specifically talking about the tree layer, multiple stories within the tree layer, in addition to the shrub and the herb and the moss. And then you'll also have differences laterally because this is a landscape that we're talking about. So how impenetrable it is going to depend on type of forest and the level of disturbance. So when you
Mhm.
think about, these tropical rainforests that you can't even walk through, that is not really what most of the time it's going to be like. That's really only going to occur if you have some sort of disturbance. So if a tree falls and suddenly you're getting a lot of light to the forest floor, all of these things are going to start growing up as fast as they can, making it really dense until that gap closes again. And the things that didn't make it up to the top are going to either die or die back. Another disturbance is going to be things like rivers.
Yeah.
So again, if
Mm.
you're along the edge of a river where you're having light coming in, it's all about light, yo. So if the
Yeah.
light is coming in from the side, you tend to have way thicker forest and gallery forests and things that are along a river than you necessarily have like in the middle of nowhere in a forest. So even within the same type of forest, in different parts of the world, they'll have different structures. So, for example, a tropical rainforest in Africa is going to have a different structure than a tropical rainforest in South America is going to have a different structure than a tropical rainforest in Southeast Asia. And so, saying tropical rainforest is not enough to really describe what that is structurally, which is the point that I was arguing with the reviewer about.
Yeah, yeah. Well, I definitely get that because I've noticed that when I would like watch documentaries and they'd be like, yeah, this, or when I was in Australia,
Mhm.
we were traveling and they were like, yeah, this is a rainforest. It's like, oh, that doesn't look like my mental image of a rainforest because my mental image is the Amazon.
Correct.
Mhm.
Like that's what I think of when I think of rainforest because that's the one that most documentaries use as their example.
Yes.
But I was like, yeah, that makes sense that you can have a rainforest here, but that doesn't look like what I think of as a rainforest because it's a different kind.
Right, exactly. And like the types of plants, the groups of plants are really going to impact what it is like structurally.
Yeah. It's really interesting to think about a forest almost uniquely among biomes, because a lot of biomes are defined in part by their plant life,
Yes.
because plants form the foundations of ecosystems. But forests are unusual in that the plants aren't just a key to identifying the type of biome. The plants are physically the biome.
They are
Yeah.
the
That
house.
Yep.
yeah, that is, the plants are where, like a grassland, you're walking across the grass and you're walking over the grass and you're feeding on it. But a forest, a lot of the habitat space itself is inside or on the plants themselves.
The way that I think about it is the difference between like a stage
Hmm.
and a house. Right? So
Yeah.
if you, because a grassland is a stage, right? You have, looking into the horizon, you have what's in front of you. Like, it is in many ways, as much as I hate it, it is kind of the background.
Yeah.
Hmm.
But the forests, like, we'll talk about this more, the animals are living in and around and on and just integrated in the plants in a way that is not there isn't really an equivalent in other types of biomes that aren't some kind of forest.
Yeah, yeah. The only other thing that comes to mind for me is like kelp forests,
Right.
Yeah.
There's
which
a reason it's
is,
called a forest.
yes,
Uh-huh.
exactly.
And I think it's emphasized so clearly because there's so many examples of like forest dwelling animals that are famous for, yeah, this animal rarely, if ever, touches the ground.
Right.
Hmm.
Like
Exactly.
their entire life is spent up in the trees because that's how this environment works, that there are so many trees you can just stay up there moving from tree to tree and live your entire life however many tens to hundreds of feet above the
Right.
ground.
Well, and there are plants that spend their lives living on other plants. Like,
Yes.
it's the house.
Well, let's get into some of the more details of the ecosystem. So you've mentioned a bunch of times already, alluded to different types of forests, and I can think of some different types, but let's get into that. What are some of the major genres of forest?
There are a couple of axes that you can use to categorize forests. So there is the evergreen to
Mhm.
deciduous axis, right? So basically, do they keep their leaves all year round or do they periodically drop them? And then you have the tropical to temperate to boreal axis. So this is basically temperature versus precipitation. Not 100% because sometimes it can be temperature that makes them drop their leaves. But in general, this is precipitation versus temperature.
All right, so it's like a graph, and you can place
Yes.
different forests on the X and Y axis.
So there
Mhm.
is a graph that I took all of this from. It's called a it's called a Whittaker diagram. It is my favorite graph of any kind. So
Cool.
basically it has temperature along the x-axis and it has precipitation along the y-axis. And you can this is what we use in paleoclimate research to plot biomes. So we're going to get into this multiple times. But yes, diagrams, my favorite thing. I love them so much. Okay, so there are broadly 5 categories of forest that we're going to talk about today. There are more things in a Whittaker diagram, but I'm only talking about forest. So there are tropical forests. You have tropical rainforests and tropical dry or tropical seasonal forests. So these are deciduous to semi-deciduous, temperate rainforests and temperate deciduous forests, and boreal forests, which can have evergreen to deciduous.
Okay.
Okay.
Which I did not realize until I started planning for this episode, and I feel betrayed. I feel like someone should have told me this at some point. So, we are going to start with the tropical forests and going to work our way colder because I'll admit tropical rainforests are my favorite.
They have all the best animals in them.
I mean, they're pretty great. Let's be real.
Mhm.
They have some good I found some great fossils that were from tropical rainforests. So we're gonna start with that. So tropical rainforests may be the most charismatic biome.
Mhm.
Like I think that is not a hot take. I think that's true.
Yep.
They are very limited in a lot of ways. They are very restricted.
Mhm.
So they are only found in the tropics. They are between 10 degrees north and 10 degrees south latitude. That's pretty much it. And their temperature range is between 20 degrees Celsius and 30 degrees Celsius, which is between 68 to 86 degrees Fahrenheit. And so this is the mean annual temperature. It can get
Mhm.
hotter, it can get cooler, but in general, the mean annual temperature, the average temperature, is going to be 75 ish degrees,
Yeah.
25 ish degrees. Really comfortable. I mean, humid as all get out, but really comfortable in terms of temperature.
Humid
Uh,
and buggy, but
oh
Yeah.
my goodness,
but you
yes.
don't need a sweater.
Exactly, pros and cons. So in terms of precipitation, these are wet places. So they'll get between 2.5 to 4.5 meters of rain per year.
Wow.
Meters. Which is between 8 and 15 feet of rain per
So that's
year.
why they call it that.
There's a reason they called it that.
I always used to wonder where they got the name from. Now it
And
makes sense.
and importantly, while they will have wet and dry seasons, even the dry season, no month receives less than 1 centimeter or roughly 4 inches of rain.
Yeah. Well, you mentioned earlier the way that the canopy spaces out
Yeah.
and sort of reduces the
Yes.
incoming rain. And in a rainforest, I would imagine that it is basically true that you are almost always going to have water dripping down, because I can't imagine that it's ever been long enough since the last rain that the trees aren't still dripping.
Well, and there are some places that get just truly mind-boggling amounts of rain. So I believe it's Gorgona. It's in, I want to say, Colombia, but it's like northern South America that gets like, I don't even remember. It's more rain than that. Like it is above the 4.5 meters of rain. It basically rains all day,
Yeah.
every day. It is just constantly raining. And the funny thing about that is it's always an outlier in our data sets because it's so wet that the leaves have to deal with the fact the trees have to deal with the fact that the leaves are constantly wet, and that just leads to fungal growth.
Yep.
Yeah.
And so they have this whole different, they're not following the normal trajectory of like leaf size because they got other problems going on.
these are aquatic trees.
Basically.
Yes. Yeah.
Basically. So, major regions with tropical rainforests. This is probably not going to surprise you. Tropical America. We're looking at you, Amazon. West Africa and the Congo Basin in Africa, and the Indo-Malaysian region of Asia, so Southeast Asia. That's it. That is where we really see the bulk of tropical rainforests today. That is not necessarily the case in the past, but generally speaking, those are your three areas. In general, trees in tropical rainforests, they tend to be broad-leaved evergreen trees. You have a multi-storied canopy, mostly trees with some climbers, so that's like vines, lianas, things like that. Trunks are relatively narrow, so less than a meter or 3 feet in circumference. If you are accustomed to trees from other parts of the world, they're going to look immature.
Yeah.
Like that is not a very big tree, but I mean there's a lot of them. The average height of the tallest trees is less than 55 meters, which is between 150 and 180 feet, which is taller than the tall trees than we'll get like here in Eastern North America. That's bigger than our tall trees. But it's shorter than what you get on the west coast of North America or in Australia. The gums are taller too. So there's a lot of morphological uniformity in tropical rainforests. The trunks tend to all be straight and slender with branches at the top. The bark tends to be thin and smooth, and the leaves all tend to be evergreen, elliptic, dark green with entire margins, so smooth edges, and a drip tip.
Yeah.
Which means that using like you have to use other things to identify them.
Yeah, makes sense. I guess there's only so many ways to be a successful tree in what is really quite an extreme environment.
Yes, it absolutely is. And the thing about tropical rainforests that makes them very different from, say, like temperate forests is that any given species is going to have a very, very, very narrow range. So you have a lot of species with very small ranges, as opposed to, say, deciduous forests, where you'll have fewer species with massive ranges. But yeah, no, like, that was the hardest thing about working on my tropical rainforest leaves, is they all look the same. I had, like, I spent a lot of time staring at leaf venation because nothing else, everything else was the same. So we're going to move on to the tropical seasonal forest, right? So this is the same temperature range, right? Between 20 and 30 degrees Celsius, but we're getting less precipitation. I mean, we're getting 1.5 to 2.5 meters. So it's still a lot.
Hardly any.
Dry as practically a desert.
Right? I mean, basically. So about up to like 8 feet, not absurd amounts of rain. But this is seasonal. That's the important thing. That unlike the tropical rainforest, you might only be getting a few inches of rain. You are getting precipitation all year round. This is much more seasonal. The other thing with this is that once you get on the dry end, it can be difficult to differentiate like the ecotone, right? The edge between a tropical seasonal forest and a savanna, like it gets kind of murky. So these used to be more widespread than tropical rainforests because they're not restricted to that narrow band. But now very little of that remains. So major regions with tropical seasonal forests are southern Mexico into Central America, South South and Southeast Asia, northern Australia, and Africa, both north and south of the rainforests.
Oh, interesting.
Okay.
Okay.
So it's basically a sandwich.
Yeah.
Yeah. Now, when you said that seasonal in the sense of like there's a wet season and a dry season.
Yes, but seasonal, not just that, but also they tend to drop their leaves.
Yeah.
Oh,
Gotcha,
sure.
gotcha.
Yeah, that makes sense.
And I'll get
They
into that in a second.
Experience autumn.
Yes, of a
Uh,
sort.
When you said that these used to be much more widespread than tropical rainforests, I assume that you meant geologically speaking,
No.
or did you mean historically?
I mean historically.
Okay, gotcha. I was
Oh.
wondering, like,
It's an us
not
thing.
it wasn't the ravages of time have taken the temperate, the seasonal tropical forests from us. It's that the ravages of our species.
Us.
Yeah, it's a little bit of both.
We were the ravages the whole time.
We were the ravages you made
It's a
along
fan
the
along
way.
the way. Yep.
Noted.
So it is like season. You have dry season and wet season, and for many of them that corresponds to, as you said, an autumn. But tropical seasonal forests are very variable. They are highly variable. So it's actually very hard to generalize. Tropical rainforests, I could say a lot of bold statements that is broadly true. Tropical seasonal forests, that's a lot harder. So for evergreen, so ones that don't drop their leaves, to semi-evergreen, so the majority do not, but some do, they have 3 canopy layers. So only the uppermost canopy layer will have deciduousness.
Okay.
Right. So if they drop their leaves, they only drop the top leaves.
Oh. All right. See, I thought you meant like
So like the
only
trees that like the trees at the top are the
Yeah.
ones. Yes, but that means that like you'll still have 2 layers. Most of the canopy will still have leaves.
Yeah, and those other layers, those would be other trees, like other
Correct.
plants.
So that you would have like the tallest trees presumably are the ones that are dropping their leaves, and then like the middling members of the canopy not.
Yeah.
That's interesting because I would have guessed the other way. I would have guessed that the evergreen trees are the tallest ones because they get light and photosynthesize all the time so that they could grow taller. But I guess maybe deciduous trees have to like sprout way up there to get enough light.
I have
Or-
many questions. I have many questions about this.
Great. We'll reach out to a paleobotanist and see if we can.
I don't like it's one of those
We
things
need an
I don't
expert.
we do need an expert. I also don't know which one would have been intuitive to me, you know? Like
Yeah, they both make sense.
like
Yeah,
yes.
Well, I can see this logic potentially if at that higher level you're experiencing the seasonality differently. You know, if you're experiencing air currents differently, if you're
Right.
experiencing things differently, and that them losing their leaves could allow more stubborn plants to then take advantage of the light that they're now going to let through and muscle through the tough time that the big plants decide to save energy on.
The thing that I always forget and that I'm just aggressively reminded of is the fact that there is a physics component to all of this, right? And so like that is the thing that I always forget to consider. And I would not be surprised if that is therefore the reason why I didn't think of this. So okay, so we did the evergreen, semi-evergreen, and then there's semi-deciduous to deciduous. So basically we're getting to a higher proportion of trees that are going to be deciduous. So they actually only tend to have 2 canopy layers instead of 3.
Okay.
But even within this, deciduousness varies from year to year, from site to site, from species to species.
Hmm.
Oh.
Right. Because it is a response to the environment.
Yeah.
And a lot of this has to do with dry seasons, not with like temperature and darkness. So, because
Right.
that's the hard thing for like those of us who are accustomed to, temperate deciduous forests.
Yes.
The reason for that seasonality is the fact that it gets really cold, it gets really dark, and the plants are cutting their losses. This is drought.
Yes.
Right. So yeah, if you don't have to drop your leaves, you
Yes.
don't. It's a real pain in the butt to do that.
Correct.
Though there is a trend to wet season, dry season, it is not near like you can have worse and summers and winters,
Yes.
but you're gonna have summer and winter every year because once again the planet is
Correct.
deciding that for you.
Yes.
Like
Yes, exactly.
it is given the sun the cold shoulder or not,
Yes.
but how much rain you get can be extremely variable because did a wind pattern just not make it the same way? Did an ocean current act weird this year? You might not have a dry season the way you did last year.
Right.
And so yeah, that's very interesting. That is very alien being a
Yes.
temperate person,
Yes.
but that also makes all the sense.
Absolutely. The other thing too about tropical seasonal forests is they tend to have fewer epiphytes, so plants that are living on top of other plants,
Okay.
than rainforests, but they have lots of climbers, so lots of vines.
Okay,
Huh.
interesting.
So not necessarily more than you have in a tropical rainforest, but they have a lot.
Interesting. I wonder if it's harder to be an epiphyte to live on a plant if there's not that constant moisture to water you.
Right.
It's like, yeah, now when things dry out, I don't even have the soil to fall back on.
Right.
This branch is just going to dry out and I'm going to die.
Right. And if you're in a place where like the canopy above you also they drop their leaves,
Yeah,
like,
yeah.
"Oh, I wasn't prepared for this."
Just your umbrella disappears and you're in the sweltering sun.
Correct.
Yeah, interesting. I wouldn't have ever thought of that being a distinction, but climbers and
Yeah.
things growing on plants but growing in different ways matters.
Yes. So, okay, let's move into the temperate region.
Yep. Well, moving up or down.
Yes. So, temperate rainforests.
Mm-hmm.
So, these are what it sounds like. They are very wet forests that are in the temperate region. So, higher latitude, but not the highest latitude. So, moving north and south. So, these have a much wider range of temperatures than you had for the tropical forests. So, these can be between like 8 and 20 degrees C, which is between like 46 and 68 degrees Fahrenheit for average temperature. So, definitely cooler. They're getting between 1.75 to 3.25 meters of rain per year, which is between 6 and 11 feet. The definition of a temperate rainforest varies around the world. And so, like, the North American definition might not encompass like Australian types of tropical seasonal forests, but generally speaking, they are temperate forests, get a lot of rain. So the major regions for temperate rainforests are the Pacific Northwest,
Yep.
which I'm sure comes as no surprise.
I was in some temperate rainforests this summer.
Yeah.
Southern Appalachia, so where you are
Mm-hmm.
in Tennessee, that is a temperate rainforest.
I have heard that before. Yeah.
Yeah. So, fun
All right,
fact.
I guess I'm in a temperate rainforest every summer.
Yes, you are. So southwestern South America, New
Mhm.
Zealand and southeastern Australia, northwestern Europe, so like the UK, southern Japan, and the Black Sea Caspian Sea region. And so if we think about where all of those are, with the exception of where you are, all the other ones. So in the northern hemisphere, you have the Pacific Northwest and northwestern Europe. And then in the southern hemisphere, you have both the southeastern Australia and southwestern South America. Don't think about it too much, but you tend to be coastal, right?
Yeah.
Yeah.
Yes.
You're coastal in that there's a mountain range there.
Yeah, it's a coast.
Yeah,
Yep.
of some kind.
We're on the coast of the mountains.
Exactly. So these can be coniferous, so they can be conifers, gymnosperms, or they can be mixed forests. They can be primarily broadleaf. Like there's a lot of different types of forests that can fit into this umbrella. Mosses and ferns are very common in the understory, as you know.
Yep.
The tallest trees can be more than 100 meters. So that's 328 feet. This is
Yeah.
going to include things like your redwoods,
Mm-hmm.
right? So, like, the tallest trees live in these sorts of environments. It is also the rarest type of forest
Oh, interesting.
because it is the most logged.
Once again,
Oh.
rarest now in
Uh-huh.
2025. They are the rarest forest. Yeah.
Correct. Because, I mean, if you think about it, you have really, really, really tall trees here.
Mm-hmm.
And
Really
if
big
you-
trees and lots of people.
Uh-huh.
And also
I was
they're
gonna say.
coastal, which is also where people
Yeah.
live.
Yes,
I was
exactly.
gonna say a lot of the places you mentioned were very heavily populated
Yes.
areas.
Yes.
Uh,
They're really nice places to be. And also, capitalism. So yeah, this was there it was actually, again, it's hard to make generalizations about this type of forest because it's relatively rare now and it can be so many things. And that's kind of a refrain for this episode, is that there's no one way to be a forest except for a tropical rainforest kind of.
yeah.
So, my other love, the temperate deciduous forest, that's where I'm living now. I love it here. So, these are places with temperatures between 5 and 20 degrees Celsius. So, between 41 and 68 degrees Fahrenheit. And again, these are the mean annual temperature. It's going to get warmer, it's going to get cooler. This is the average temperature. When we're looking at precipitation, it's getting lower, right? So between half a meter and 2.25 meters, so between 1.6 feet and 7 feet, way less precipitation.
Mm-hmm.
And especially in this kind of environment, this is precipitation, not necessarily rain. This is also going to include snow. So this dominates your less arid middle latitudes. This is a very, very common biome, right? So you see it all across eastern North America, from Canada through the United States. It was the historical biome of Western Europe. It is the historical biome of East Asia, in southern South America, and in southeastern Australia. So again, in these similar sorts of environments. We're gonna talk more about like the history of these biomes in a little bit. I just want to kind of orient us. And then finally, the boreal forest / taiga.
Yeah, the cold ones.
The cold one. So these
Yeah.
have a mean annual temperature between 0 and 8 degrees Celsius. These are cold places. So
Yeah.
between 32 and 46 degrees Fahrenheit. They're getting between 0.25 and 2 meters of precipitation. So this is much drier. So that's between less than a foot to 6.5 feet of precipitation each year. So this is a northern hemisphere biome.
Right.
Yes.
There are no boreal forests in the southern hemisphere.
Because your choices in the southern hemisphere are either the southern continents that are mostly pretty tropical to temperate, or Antarctica, which is ice.
Right, exactly. Well, and if you think about the shape of continents, you have very narrow southern continents and very wide northern continents.
Well, that's something I've been thinking about this whole episode, because we've been talking about, the rarity and the like dispersal of, that like tropical rainforests actually have a fairly narrow, range that they can be in. But all of this really depends on where our continents are right now. Like,
Correct.
if we had a continental belt around the planet, then we'd be a tropical rainforest planet. Like we would be,
Like
that
we
would be what
were
defined it.
before.
Yeah, that would be what
Yes.
defined us.
Yes.
This is all true in the modern world with our modern
Yes.
climate and our modern continental arrangements.
Yes.
But there's no reason you couldn't have had boreal forests in the southern
Yeah.
hemisphere in the past, and I'm sure
Correct.
we did.
Correct.
Yes.
That's exactly it. Like this was very fun for me because as I was going through this, I pulled up Ron Blakey's maps and I was just going through time and just watching the orientations of the continents and noticing again like how much landmass is in the tropics versus in the temperate regions and how much dry continental interior there was because that's also very important. But we'll get to that. We're gonna back to the boreal forests. So they are currently in our modern world limited to the high latitudes of the northern hemisphere. So their northern limit is the Arctic tree line, which is where there's permafrost. And it's hard to be a tree when there's permafrost.
Permafrost, dear listeners, is frozen soil.
It is
Yes.
permanent frozen.
It is permanently frozen soil, and that is a hard limit for plants.
Yes. And so this is between 58 and 68 degrees north latitude. It varies across, like it's different in Canada versus in Siberia. But you can actually have types of boreal forests in high elevation, high altitude.
Okay,
Because
sure.
going up in altitude is the same as, you know, going into your higher latitudes.
So alpine forests.
Yes.
Yeah. Also, the term northern tree line is so cool.
Yes. Yes. This is as far north as trees can go.
Like,
Yeah.
it is very rare that we see examples in nature of like a definitive distinction. Like,
Yes.
like you know, it's like where does a desert start? It's like, like,
Here-ish.
it starts getting sandier and sandier, and then you're definitely in a desert. But
Yeah.
here's it's like, no, this is we could almost draw a perfect line. This is where northern forests stop because beyond this it's impossible, and it's almost an off on, and that's really cool.
So these boreal forests they cover like 30% of the Earth's forest area.
Mhm.
Little less than 30%. It's the largest land biome.
Yeah.
Well, and it's also mostly continuous in a lot
Yes.
of that region,
Mhm.
right?
Yes, it is. And it's funny because a lot of the information that I used to plan for this episode, I got from my favorite textbook from undergrad, Biomes of Earth. And
Ooh.
I
You
have
know you're in
gotten-
a nerd podcast when the guest says my favorite. Listen, I also have favorite textbooks. I got some on my shelves.
I took terrestrial biomes in undergrad. One of my favorite classes I've ever taken. But even in this book, I feel like they're throwing a little bit of shade at the taiga and like monotonous for hundreds of kilometers. Like, whoa,
Oh,
rude.
Well, when we think about because you've been talking about forests this whole time and where they're
Yeah.
distributed, and you've got tropical rainforests and this, and this spot. There's sort of a patchy distribution, but boreal forests are almost a complete band around the northern hemisphere of the Earth.
Yeah. Yeah. And the funny thing about that too is they're also not they don't have a lot of species.
yeah.
Mhm.
And so like you have these very impressive ranges for these plants. So there tends to be relatively few tree species. Most of these places have a history of fire. Like fire is very important to these forests. And
Interesting.
bogs and wetlands are very common,
Oh, sure.
which makes sense cuz glaciers.
Yep. Yeah.
There's a lot of
Especially-
suspicious holes filled with fresh water.
Yes. The funny thing about the boreal forests is that they are there because of they're there partially because of the glaciers, but also they look like they're there because of the glaciers, right? It's like the glaciers could still be here. So in general, these forests tend to be coniferous, right? They tend to be primarily gymnosperms, they tend to be primarily conifers, except, and this is what I talked about at the beginning, in the really inhospitable parts of Siberia. Eastern Siberia is apparently real rough climatically. And in that region, you actually have primarily deciduous plants. And so you'll actually have angiosperms.
Hmm.
So, in addition to larches, which are deciduous gymnosperms, you'll also have aspens and birches. And I think that's so funny because oftentimes, like when I've been talking about like the extreme plants, it's the gymnosperms. But in this instance, when being deciduous is really helpful, the angiosperms are like, I got this.
Yeah.
Interesting.
Yeah, and unlike the other types of forests, which tend to be multi-storied in many cases, these are single story canopies. And that also makes sense. There are fewer trees, they're not quite as dense. Vegetative reproduction is common.
Oh,
Yeah.
sure.
And that makes sense that you're not going to try to send out seeds that need to find a way to survive and become a little baby tree. Instead, if you can just like shoot off a root sucker or something that's
Mm-hmm.
already well on its way to being a plant that's going to be able to survive, because the number of frost-free days that you'll get in the taiga can be very, very low. So the
Yeah.
growing season here is not very long. That's part of the reason why it's so useful to be evergreen, so that you can try to maximize, the amount of energy, amount of photosynthesis that you can do. The ground layer tends to be very shrubby, so heaths, things in ericaceae, scattered herbs, lots of mosses and lichens. But yeah, it's in stark contrast to, say, the tropical rainforest, right?
Mm-hmm.
Like the structure is way simpler, the number of species is way lower. But with that, we have traveled the world and looked broadly at the major groups of forests.
The boreal forest stands out to me in a really interesting way because it is a forest in a very inhospitable environment. Like, this is extremely cold. This is tough for life. Like,
Yes.
most forms of life would struggle to live here. The animals and plants that do live there are very specialized for how cold and dry and barren it can be. But a vast majority or a huge proportion of our landmass is in that region.
Yes.
Like, our continents just are all shoved up into the top of the planet, top from the way we face our globes.
Yes.
So there's a lot of real estate in this really harsh place. So it's our biggest forest. And it's the reason that stands out to me as so peculiar is because, like, that's not what we see in all situations. Like, the open ocean is our biggest environment,
Mhm.
but it's pretty sparse.
Right.
It is not full of life because it is effectively a desert. But here's a situation where I would have expected it to be the same if I didn't live on Earth.
Right.
Like, if I didn't know about the boreal forests, but
Right.
I would expect it to be the same of like, well, yeah, and then there's basically this giant desert up north because what can live there? It's like, well, no, but things can, and then the few species, not a lot of species, but the few that could made a global forest, basically. That's so cool.
And this is fun too because it is a hint at the past.
Mm-hmm,
Right,
mm-hmm.
because this makes it way easier if I tell you, yeah, there were land bridges, yo. This was connected. Like
Mm-hmm.
very
Yeah.
easily, very recently connected. And so that's a nice, if you believe me for that, that it'll be easier for me to talk to you about other parts of the world that previously were more connected.
Yeah.
Yeah. Well, and it's also it's interesting to think about because we were talking. This came up recently in the Bears episode 217, when we were talking about the distribution of
Mhm.
bears. And you'll notice a trend. A lot of northern dwelling, especially large animal species, have an extremely wide range, right? Wolves, moose, bears. And part of the reason they're able to do that is because the biome itself that they are living in and around is so expansive.
Yes. And that is a great transition
It is.
into who lives in the forest.
So forests, like any biome, forests are going to have particular types of plants and animals that tend to thrive there. Aly, what types of plants and obviously trees, but beyond the trees, what sort of species tend to make their homes in forests?
All right, I'm going to make you guess. Ready?
Oh, great. I'm
I
so
have a question
excited.
for you. Okay.
Trees.
So, what percentage of terrestrial species live in forests?
All species? So plants and animals?
Yes. So, vertebrates, invertebrates, plants, fungi, everybody.
What percentage of land species live in forests? I'm going to say 80%.
Okay.
I was going to say 70.
All right.
80%.
Yeah.
Nailed it. I know so much about plants.
And animals. So 80% of terrestrial
Wow.
species. That's
Yep.
most things.
Yeah.
Well, and that was something I thought of when you were talking about how limited tropical rainforests are. It's like, yeah, but they are our most
Yes.
biologically dense environment on the planet.
Correct.
And it's like, forests do good work.
Yes. Well, so I'm going to read some stats to you, which kind of blow my mind. Okay. So 80% of terrestrial species live in forests. Forests make up roughly 31% of terrestrial land area.
Wow.
Okay. All right. Keep going. So, an estimated 50% of living terrestrial species are found in tropical forests, which cover 7% of land.
Yep.
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 Well,
That's so dense.
it makes a lot of sense when you consider that, A, like you were saying before, boreal forests tend to be fairly broad and homogeneous.
Yes.
Mhm.
Whereas in tropical forest, you mentioned a lot of species have very narrow ranges.
Mm-hmm.
Also, outside of forests and terrestrial ecosystems, your other choices for places to live tend to be grasslands, deserts, or tundra,
Yep.
Yep.
which harder. But going all the way back to what we were talking about way early on, forests are vertical.
Yes.
You have
So-
increased real estate.
Yeah, you've got all of
Yes.
this vertical space for it's one of the reasons why it's how you pack so many people into Manhattan or Tokyo.
Yes,
is
exactly.
You build your buildings very, very tall and
Yes.
fill them with homes.
Yes, exactly. I mean, trees are skyscrapers. That's what they are.
Yeah.
So the fun thing for me about forests is it really does illustrate differences between plants and animals. And what I mean by this is tropical rainforests everywhere in the world have this pretty much are dominated by the same plant families.
Mhm.
Everyone. So Ananaceae, which is your custard apples, Euphorbiaceae, which is the spurges. So these are the things that look like cacti but are not cacti in say Africa. But also Moraceae, which has your figs. So ficus. Ficus, that genus is found pretty much everywhere in the tropical rainforest. Myrtaceae, so these are this is the myrtle family. This includes things like eucalyptus and tea tree. Rubiaceae, which when I was doing my dissertation work, Rubiaceae was found pretty much everywhere and was a dominant family. But here's the thing. These groups are found in temperate regions, but are not particularly prevalent. But
Interesting.
it is wild. You go anywhere in the world to a tropical rainforest and you will see them dominated by these same plant families. Sometimes you'll have others that'll be dominant too. Fabaceae, so that's the bean family. It's very common in Africa. Lauraceae, but in general, it's pretty much the same. And that is not the case with animals. You have
Mm-mm.
niches that you find in pretty much every kind of forest, but who is filling it is fundamentally different.
Yeah.
So, rainforest plants rely on animals for pollination and seed dispersal. And so, most of the flowers and fruits are in the upper layers. And so that's where those sorts of animals need to be, your birds, your bats, your insects, your primates. But as I was mentioning, the role of tiny fruit eater on the forest floor. So you can have agoutis doing that, which are rodents in
Yep.
South America, but deer,
Yep.
Yep.
mouse deer in Asia, royal antelope in Africa. You can have in South America, you have the peccary, and in West Africa, you have the forest hog or the bush pig, and in Asia, it's bearded pigs or barbarossa. Like, it's wild that there's just this shape is good. Find me an animal
Yes.
that fits
Yes.
this
Yes.
shape.
Someone who will eat off the floor.
Yes, exactly. But even like small predators, you have your ocelot in the Americas, your
Mhm.
golden cat in West Africa, your clouded leopard in Asia. Like, it's so fun. It's okay. So you know those, you know when you have like the silhouette, right? You have to like, oh, guess what
Yes.
is it? That's what this feels like. There's just so
Mhm.
many things that you can plug into these niches, and like, I don't know, who you got?
Mhm.
Yeah.
Mhm.
It's really I think for me the immediate thought that I think of when the question of what lives in forests in terms of animals comes up is arboreal things,
Yes.
Hmm.
because living in trees is such a very common habit of animals that we have around the world. But forests are really the one place where you can do that in a hyper specialized way.
Yes.
And this actually will come up in the fossil record. This
Hmm.
has come up in discussions about the gray fossil site,
Hmm.
because there's been lots of discussion over the years of how dense was this forest? Was this a more open woodland? Was this a denser forest? And one of the points in favor of denser forest has been, well, we have red pandas and
Hmm.
we
Yep.
have gliding squirrels. You
Yes.
have these animals that spend all or most of their time in and between the trees, and you can't do that in an open forest,
Yeah.
right? You
Right.
can't do like a monkey or a sloth, right? Sloths are that when Will was talking about animals that never come down to
Yes.
the ground, that was
Yep.
the animal in
I
my
was
head.
thinking
Is
sloth.
yep. You can't be a tree like that. Only works if you can go from tree to tree.
Right.
If I have to commute across the ground every time I want to go up a different tree, that completely ruins the entire game.
Yes, you also get here in the Americas. There's lots of monkeys that do that.
Mhm.
Orangutans are another really good
That's what
example
I
of
was
that.
thinking of.
Yep.
Yes. But in addition to that, you mentioned gliding. You can only glide if you don't have too many obstacles.
Yes.
Yeah.
And that gets into the structure thing, right? Because you have forests with a whole bunch of different things that can glide, and then you'll go to the tropical rainforest in a different part of the world, and nobody's gliding because it is a different type of
Yeah.
forest.
Yeah.
Yeah, you get a lot of gliders in tropical rainforests in the eastern hemisphere
Yes.
Mhm.
and less so in the western hemisphere. You were talking about the convergence of things in forests, and one of
Yes.
my favorite examples we talked about in episode 196 is in the Americas, in especially tropical forests, you get arboreal boas,
Mhm.
and in the old world, you get arboreal pythons.
I love
Yep.
that.
And some of them you get your green tree python and your emerald tree boa, which are almost indistinguishable animals despite being
Yeah.
in completely different families.
Right, right.
Well, that was the thought I had talking about like animals are different players but filling very similar slots in the forest.
Mhm.
This is definitely not an actually true statement, but I definitely have had the feeling for where I've seen an animal that I wasn't familiar with and have the thought of that looks like a rainforest animal.
Mm.
Like that
Hmm.
looks like an animal that lives in a rainforest because it's, that frog's too colorful. That frog, this animal is just doesn't look like it would fit in a temperate forest. It looks like it fits in a tropical rainforest because it is a different kind of place to be in. The animals tend to lean in very similar ways to survive there, and that's cool.
Yeah.
So let's move briefly to temperate forests and looking at the types of plants and types of animals that can live there. So, one of the cool things about temperate forests, particularly in the northern hemisphere, is the disjunct. So, if
Yeah. We
yes,
talked about this in episode 219 about Beringia.
yes.
Yeah.
So, as we were mentioning with the boreal forest, like, oh yes, this is continuous. This used to be true for the temperate forest. You had land bridges on both sides of what is now North America, both ends of Eurasia, and you had this trading, right? You have this, continuous band of this forest. And now that is not the case. It is not continuous. And also there's grasslands in the way in multiple places. But it is really interesting and very obvious the similarities between the plants that you will see in Eastern North America and in East Asia. Like you'll get the same families, same genera, and you might have different numbers of species. So this could be things like viburnum, witch hazel, liriodendron. You'll see them in both places. And similarly, you'll have these animals with these enormous ranges that are found in, like, moose. They're
Yep.
just everywhere.
Yup.
Right? The deer, the bears, the wolves, foxes, squirrels, lynx, marmots, like they're just everywhere throughout this. And sometimes you have the actual same species with absolutely enormous ranges.
Yup.
Yep.
Yeah, gray wolves are like that. Brown
Yes.
bears are like that.
Yes.
And moose.
Yes.
Even though they don't call it moose over in Europe because of historical naming things,
Yes.
but that species, what we here in the US call moose, and what is historically was elk.
Yes. They're elk.
They're elk.
Which is wild that they basically, and that again really reinforces the fact, okay, yes, this was all one thing at one point. And then finally, unsurprisingly, the boreal forests. I already mentioned that we don't have very many plants. You have your spruces, your pines, your larches, your fir. And again, you have this basically continuous distribution of animals. You're seeing the same animals in all of these places because they were connected and they are connected.
Yeah, you get a ton of animals in forests that also not only make their living on trees, but in trees.
Yes.
It's extremely I mean, there's tons of bugs that live in trees, and then
Oh, yeah.
you get things that you'll get things that eat those bugs, so you can have an entire ecosystem that only exists 100 feet up off the ground
Yes.
Yep.
because
Wild.
that's where all those things are living.
Trees are so cool.
It's awesome.
Another type of animal forest interaction that comes to mind that I think is fun to mention is most of when we think about animals that live in forests is animals that are responding to the shape of the forest around them, like climbing the trees, living up in the trees, whatnot. But you also commonly get in forests animals that shape the forest.
Yeah.
The most obvious example, which you get over in Asia and Africa, are forest elephants.
Yes.
Yeah.
Which is a
Yes.
thing that today only exists in the old world, but in the past, in the fossil record, we see evidence of this is something that has come up at the Gray Fossil Site. And one of the ways that I would always explain this to guests is the fact that we have mastodon fossils tells us something about the shape of the forest that was here. It tells us that there were mastodon-sized paths through the forest, because if there weren't before the mastodon showed up, there are when it leaves, because that's what those animals do, is they clear space through the forest.
And similarly, beavers, right?
Yeah.
You can find them across the northern hemisphere. I recently saw something, where was it? Estonia? They were talking about like, oh, we need to make a dam, and it took years and years to do it.
Yes.
And then like over the span of a week, beavers made it.
Yep.
It's like, oh, guess we don't have to make the dam now. Thanks. Saved us a lot of money. The beavers agreed. That was a great place to put a dam.
Yep. Oh, it's so cool.
Aly, we are going to go into the past and talk about the deep history of forests. But before we do that, is there any other thing that you'd like to gush about when it comes to forest ecosystems and what makes forests special?
Yeah, I'm gonna say kind of a cliche. Trees are tubes.
That's true.
And so the hydrology of forests is really important and really interesting. And it is kind of key to understanding forests. We'll talk about this in a little bit, but like tropical rainforests in particular are famous for the ways that they can move water, but all forests can do that. Trees are the way that soil water gets to the atmosphere in a forest.
Yep.
They're like smokestacks, but for
Yes,
water.
they absolutely are. And so these have a huge impact on the climate. They have an impact on animals because, again, it's going to impact the climate. And then the last thing is the human relationship with all forests is really important in some ways that are very good, in some ways that are very bad. I have talked a lot about the fact that the prevalence of different biomes is modern biomes is really related to human land use change, but the relationship between humans and tropical rainforests is still something that we are learning more and more about. And the fact that some of the diversity of rainforests is because of humans, and the fact that we will plant the plants that we like in the places where we are. So, influencing the distribution of species or, making paths is going to open up light and is going to, change things in that way. And so there is this really strong positive relationship between humans and tropical rainforest. And I just wanted to say something nice about humans. So that felt like a good note to end on for the first half.
Excellent.
Fantastic. Well, we have, as is our wont, all three of us being degreed in paleontology, talked a whole lot throughout this first half about the comparisons between modern forest distribution and forests of the past. I'm very excited for us to do a tour through time and discuss how forests have changed throughout the history of the Earth. Let's take a short break for a brief word from our musical interlude, and then we'll be back and go to the fossil record. So, Aly, in the first half, you mentioned a number of times your research examining the structure of ancient forests in the fossil record. So, I want to start with a question that I think maybe gets at precisely the kind of thing that you were doing. When we're looking at a fossil deposit, how do we know if we're looking at a forest, and how do we identify an ancient forest from fossils?
Great question. This makes me wish I had a time machine because it's surprisingly complicated. So there are lots of different ways that we can do this. Fortunately, we have a lot of tools in our toolbox to figure out, okay, what kind of environment are we getting at? If we are looking at soils, I want to lead with soils. As I mentioned before, different types of forests tend to have very distinct types of soils, and soils fossilize really well, which is unsurprising, right?
Because they're made of dirt.
They are
Yeah.
they come pre-buried, right?
Yes.
Because they're the things that do fossilizing.
Yes, exactly. Yes, exactly. Fun fact though, according to the USDA, there is no distinction between a fossil soil and a modern soil, and in order to export fossil literal rock soils, you have to have a USDA soil permit.
Huh.
It's it is
Yet more legal definitions that we disagree with.
right, exactly. So you have to get inspected. It's like, yeah, I got rocks here.
What are you planning to grow with this?
Right, exactly. So, fortunately, it's actually quite easy to study soils. So, soils can help us in a couple of different ways. The literal type of soil we have. So, there are a couple of different soil types that are very commonly associated with forests. So, there are alpha sols. So these are most commonly associated with like temperate forests or woodlands. So cooler temperatures have trees called a gray forest soil. The name alphasol comes from the fact that it is aluminum, al, and iron, f, rich.
Ah.
That's pretty great.
Yeah, so alpha cells have a lot of aluminum and a lot of iron, so they're more of like a gray color. If you find this, you're looking at something temperate that has trees. Spodosols or podsols are one of my favorite types of soil. So this is something that you'll see commonly in boreal forests, but also in some temperate rainforest soils and the tropics. So
Oh, great.
yeah, but hey, forests.
Sure, yeah, that's true. That's true.
It's paleobotanists touched rocks. There were trees here.
Yes, exactly. So the wonderful thing about spodosols is they have a very distinct E horizon. So, yes, I know.
Event horizon. By on this point, you can't get the trees back.
Not quite. So basically the E horizon has to do with the fact that it's a white layer in the soil. It's basically a white stripe through the soil that has been leached of nutrients due to acid.
Oh.
So the leaf litter of boreal forests, because of the needles from the conifers, is very acidic.
Yeah.
So you'll have this white layer. So basically, if you're looking at it, you'll have this dark brown humus layer, this really organic, rich layer at the top of the soil profile, and then you'll have this narrow white leached band. And below that, it will be yellowy orange, again, because of iron. All of these have a lot of iron in them. Then you have altisols, which are the ultimate soil. That's basically where it goes to. That is like ultimate as in the end.
Right, the final soil.
The final soil. Yes, exactly. So you'll find these in warm, temperate, or tropical forest environments. It is the red-yellow forest soil. They are highly weathered, which is why, again, it's called the ultimate. They are very iron rich. That's why they're red, and they're very acidic. And then there is the oxisol, which is basically your stereotypical tropical rainforest soil. It's red because it's oxidized. Again, it's very iron rich, it's nutrient poor. So, if you find these different soil types, that is an indication of, all right, some sort of forest here. But another thing that soil will allow you to do, but also leaves if you find them, is you can do paleoclimate proxies from soils.
Cool.
So you do it differently with soils than you do it with, say, leaves, but you can use the soils in order to get an estimate of temperature and precipitation. And that gets back to our Whittaker diagram.
Mm-hmm.
Because these, in the modern day, and again, we're doing, all we know is the modern, all that's really what we can compare to, but we can get these estimates of temperature and precipitation and plug that into our Whittaker diagram and get an idea of, all right, this is high temperature, but kind of middling precipitation. Okay, that's going to tell us something about this is probably a tropical seasonal forest. The other thing, too, is that because the plants live in the soil, it tells you a lot about this specific place. So one of the cool things that soil can tell you is about seasonality, right? Like you can look at soil texture and you can get that sort of information too. I will be so honest. When it comes to paleoclimate proxies, I really think that the best combination is soil and leaves.
Sure. I'm not
So
surprised to hear you say that.
So the reason for that is because there are some things that leaves do better and there's some things that soil do better. So specifically, temperature. Soils aren't very good at estimating temperature because of the fact that you have time averaging, right? Like by definition, soils are there for a long time.
Right.
And so you're not really looking at a moment in time in the same way. So you're getting average of temperature, but also soil doesn't really care about small changes in temperature.
I was gonna make a joke. It's like soil's like the friend that lives. When you go to college, they're the friends that's from there. They're like, this isn't that bad.
Yes. Yes.
I'm not even gonna wear a sweater.
Yes. Yes, exactly. Yes, exactly. So little like fluctuations might not phase soil in a way that, plants might like need to respond to, but soil is great at precipitation. Because when we're talking about precipitation that plants are estimating that we're using plants to determine, it's the soil or the water that's in the soil.
Yep.
Mm-hmm.
That's where it all
So
goes.
that's where exactly. So why don't we just skip the middleman and just ask the soil how much precipitation there was? And so if you are able, and the nice thing too is that paleosols tend to get preserved with leaves or like
Mhm.
closely associated with leaves. So you actually can use both. So if you have the leaves, you can estimate temperature. I have talked about this before. I will not get into the details, but if you have the temperature and precipitation and soil, the more different types of data that you have, the more you can really hone in on. And also just like, how are these things deposited? In general, the litter on the forest floor, depending on the type of forest that you have, is going to look very different. If you have a more open environment, that's probably going to look very different than a very closed environment. And it is very well documented that leaf litter in the tropical rainforest, oh boy, does that not last long at all.
Mm-hmm.
Yeah, that makes sense. All that biodiversity.
Yes,
Yep.
exactly. And it's hot and wet, and it is just like decompose me, right? So like this is not something that is necessarily going to show up very well in the fossil record. So
Mhm.
we're able to take all of these different things. You can also, if you have this kind of information, this kind of data, I mentioned that there are particular groups that, if you find them, are an indication that you are in a tropical rainforest. So if you are finding a lot of things from Ananaceae or Rubiaceae, etc., okay, this is another indication that this is probably a forest that I'm looking at. So you have to look at a lot of different things. You can't just say, I found a stump, ergo tree, ergo
Right.
forest. No. Tree is not enough.
Yes.
Mhm.
And I would assume
Mhm.
even if you found multiple stumps, it's like this could be like a copse in a meadow or something.
Well, this is true, but if you do find multiple trees, multiple stumps, if you have that along with other information, you
Right.
can basically none of these things will say, "Oh yes, forest in a vacuum."
Yeah.
You will need multiple data points, but the great thing about paleosols, the great thing about plant fossils, oh man, our sample sizes hundreds.
Yeah, especially if you're looking at pollen
Uh-huh.
and seeds. Yeah, you
Yes.
get
Yes.
tons to work with.
Pollen's not going to be helpful though, telling you if you have a forest, because that is a
Ah,
regional signal. The whole
Mhm.
point of pollen is dispersal.
that's a
Yep.
good point.
I
The
make this
soil is
point.
where the soil was.
The soil didn't move. This is
The
like
soil didn't move.
it's like
But no,
trees.
but
Yeah,
pollen and even seeds.
even seeds.
That their
Mhm.
whole point is that they travel.
Yes, that is the whole point. But that's one of the really nice things about using plants, trees, like in situ stumps, like stumps that were where they were when they were alive, these paleosols, is that like this is a local signal. It's from here.
Yeah.
Mhm.
This didn't travel. This came from here.
All dirt is local.
Yes. Well, humans like to carry dirt
Sure.
now.
Well,
We
that's
do.
why we have to stop you at the gate.
Yes.
exactly.
That's why you
That's
need
why-
a soil
have you-
permit.
Have you visited a farm in the last 2 weeks?
Are you kidnapping the soil?
Yes.
Taking it from its home?
I mean, okay, humans love to move sand around the world. It's a whole
Yeah.
thing.
Yep.
Yeah. So we can use a bunch of different types of data to say we are in a forest
Yes.
in the past.
Yes.
Can we go deeper and interpret the structure of ancient forests?
So yes, this is another thing that I got into an argument with a reviewer about. Because I feel very strongly about this, that this, specifically the structure of these forests, is the kind of missing piece. I don't think it's enough to say there was a forest here. In fact, very often, especially if you are using animals to determine whether or not you have a forest, it's simply open or closed, which
Yes.
I'll
Right.
be spicy and say is meaningless.
Mm-hmm.
I have strong feelings. I got into I've these are the things I argue with people about, but in a very professional, people want to talk to me more because of it kind of way. So we talked about what if you find multiple stumps? And I'm so confident that I have talked about this on the podcast before because that's one of the things we were able to do. So I didn't do this personally, it was before I came to the fossil site, but on Rasinga at R3, that locality in particular,
This was in Kenya.
this is in Kenya, so Rasinga Island, the best place in the world. So this is an early
Mhm.
Miocene site, roughly, I want to say 18 million years old. So R3 is a really cool site because it has both vertebrate and plant preserved there, which is not
Mhm.
necessarily the case. Very often you will only get plants or you'll only get vertebrates. You don't often get they're not completely in the same place, but they're close in time so we can begin to make some sort of generalizations. But at this locality, there were a lot of in situ stumps. So, as I mentioned, in situ means like this is life position, this is where it was. And so, because of that, they were actually able to use forestry techniques. So, measuring the diameter of the trees and measuring how far apart they were and use that to estimate the kind of canopy.
Cool.
Very cool.
Yes. So we already, based on other things, based on the soil, based on the kind of plants that we were finding, we knew this was a forest.
Mhm.
But because we had the literal trees, we were able to reconstruct it as a multi-storied canopy, which so we did the analysis on the soils, we did the analysis on the leaves, so that's telling us it's a tropical seasonal forest. We know that not only is it a tropical seasonal forest, it's a tropical seasonal forest with this multi-storied canopy, and that site was really cool because we saw differences in the types of plants that we were collecting in the proximity to the trees versus farther away. We saw differences in the soil in different parts of the locale of that site in that locality, which showed that while it was a tropical seasonal forest, there was lateral heterogeneity. There were spatial differences on the landscape. It's like, oh, here's a pond,
Right.
which was really, really cool. So again, getting at this structure, right? You have trees here, you have some open disturbance here. Other ways that you can get at that, and maybe not the same like granularity, right? Not quite as nuanced, but you can begin to get at it with looking at the leaves themselves. So leaves that are grown that grow in full sun versus leaves that grow in say partial shade, the shape of the cells on the top of the leaf are going to be different. So
Ooh.
basically, are they very like smooth edges to the cells or are they very squiggly? And so you can use this undulation index, basically how squiggly are these cells to estimate canopy cover.
Which one likes more or less canopy cover?
Great question.
Just make one up. We won't know. I assume it's the squiggly ones because the cells are dancing with joy.
That was also
how much sun they're getting.
It's for to grab the sun.
Yes, for surface area to get more sun.
Um,
We're just going to keep making stupid jokes while Aly looks this up and finds out.
They're boiling.
I was going to say, Aly mentioned the cells on the top of the leaves. And as we all know, leaves have a top.
They have a top and a bottom.
And a bottom, which we
not everybody
knew
knows
even
this.
before episode 195. We knew that.
I forgot that blew your minds.
That was that got me real good. That was one of my top plant moments on this podcast. Is leaves have a top and a bottom.
All of them?
The whole time?
The whole time. I think it's the ones with lower light are more squiggly, but I can't actually remember, and I can't dig into it right now. So
listen, someone who in our audience is gonna know.
That makes it seem like those are the creepy crawly cells. If they're the ones in the dark, they're all squiggly.
I cannot remember, and
well, it's to camouflage against the mottled pattern of the light coming through from the above.
Yep.
To break up the outline of the cell.
The fact that it's called the undulation index, though, I think is just such a good name. But
that's great.
You can use that in order to. So that's going to tell you, broadly speaking, like, in a generally, is this more of a woodland or is this more of a forest? But also, like, within a tree, where are you?
Are you at the very top of the tree? Are you lower
is this
down?
a sun leaf or a shade leaf? Yes, exactly.
Cool.
So these are basically openness proxies.
Mm-hmm.
So this will help you figure out, like, is this a multi-story canopy? Depending on where you are spatially, is there variability in how open it is? You can use animals to get at this.
Yeah.
As much as I don't love it. But as we talked about before, in forests, the animals are living like all up on in this environment, right? And one of I think this is really cool. I mentioned, I got in an argument. I was very sassy in a cover letter for a postdoc position, and I said that plants are not just the green background, and I was talking about how animals are not a good way to reconstruct ecosystems, particularly forests, because they just live in them. They are not. And that was enough to get a second conversation, because
they wanted to argue with you about it.
Because as he said, he's like, I had never considered that before. That's a really good point. Yeah, it was.
What do you mean? What more can you tell about a building than the people who live in it?
Like, oh yes, exactly. Obviously.
I don't understand.
So, ecomorphology is one way of getting at this. My favorite version of this is in ungulates, looking at the gear ratio of the ankle.
Yeah. The shape and proportions of the bones in the ankle vary between different environments.
Yes. So broadly speaking, you can tell the difference between the type of ungulate that is going to be living in an open environment that is going to be prioritizing speed. Like, I gotta run away from things.
Right. Horses, antelopes, things like that.
Yes, exactly. Versus things that are going to be going through the forest that are going to be prioritizing stability, because there's a lot of stuff on the ground.
Yep.
Yeah.
And it's going to be relying more on camouflage to not be detected.
Yeah. Which forest horses and forest antelopes, I suppose.
Yes. But also things like okapis,
yes.
the things that are hiding in the forest. And so by looking at things like that, you can get an indication of, at least broadly speaking, open versus closed environments. Another way is by looking at primate locomotion. If you are brachiating, if you are swinging through the trees, you need something to swing off of.
Yes. This is similar to the gliding. If you find gliding squirrels or something, you know that it is dense enough that there's a tree nearby,
Yes.
but not so dense
Yes.
that there isn't room to glide.
Right.
Yep.
Yes, exactly. And so the fun thing for me, the best part of trying to reconstruct fossil forests is the fact that you have so many ways to get at this question. So you can look at it from, this is the literal soil that these trees were growing in. What does this say? To, these are the literal trees. How close are they to each other? Right. This is the literal leaves. Okay, how much light were they getting?
How squiggly are they?
How squiggly are they? Or like, these are the animals that were living here. How were they moving through the space? And so the fact that we can get at this in so many different ways is really fun and does provide us with a more complete picture. Because one of the things that, as a paleontologist, there is this unfortunate knowledge that we will never actually see that which we are studying.
Yep.
For that reason, some people just straight up won't believe you. Like, well, how can you really know that? And so I know some people who are very suspicious of paleo art, right? It's like, well, how can you know that? Like, you're just making that up. But in some of these instances, we're able to really bring a lot of information, and especially when we're working with the more recent past, right? When we're in the Miocene, that's basically recent, right?
Yes.
23 to 2.3 million years ago, that's the Neogene. That is basically recent. So we can make some assumptions and be pretty confident that we're not too far off base.
Yeah.
Yeah.
Very
Aly,
cool.
while we're on the topic of fossils and forests, this is a question that I just thought of, so it's not on the outline, and it's a
Oh,
very
no.
brief. It's a very brief little quick question.
I'm ready.
Could you just very quickly mention
Every forest.
the relationship? Name every forest. The relationship between modern forests and the fossil record, which is to say, we paleontologists do a lot of excavating in like the Badlands and in
Yeah.
like deserts, but very little fossil excavation takes place in forests.
Of the 80% of terrestrial life that you find in forests, paleontologists are not
Yes.
among them.
This is true. So this gets into preservation.
Mhm.
Because the great thing about forests for life is less great for fossils.
Mhm.
So let's talk specifically about like the Miocene, right? The Neogene. So 2.3 or 23 to 2.3 million years ago. So this is what I studied during my master's. So if you are interested in that time period in North America, you go out west because there, like you said, you go to the Badlands. There are all sorts of places across the West that you have these exposures of rock. That's what you need. You need the rocks to get the fossils out of.
Yes.
And so if you go to the Badlands, you know what there's a lot of there? Rocks.
Yep.
And they're easy to get to. And you can't get big leaves out of small rocks. You need to be able to get big old chunks of rocks out of the wall. But when you get into the eastern part of the continent, you run into a lot of obstacles. So you run into the fact that you have this forest that is covering the rocks.
Kind of in the way.
It absolutely is in the way. You also have people who have built on the rocks.
Mhm.
So
Because
like
this is where all the trees are.
this is where, yeah.
Yep.
So the humans are living on the rocks and the trees are living on the rocks. So there are very few places where you have any sort of exposure. That's part of the reason why the Gray Fossil Site is such a big deal.
Yeah.
Is because you don't have macro fossils, so like actual large fossils, not pollen, from that time period, from that part of the country. So you're looking for places where you're looking for basins, right? When you're trying to excavate. The fossils form in places where they're being deposited, and then you are able to uncover them in places where they're being eroded. But land cover, I am frequently fighting with plants, modern plants, to get to the dead plants because they're
Yep.
rudely growing their roots through my dead plants.
I also
Yes.
want to play in the dirt.
Yes, and so that's why it is really, really hard to find fossils in
Mhm.
places that are today forests.
Yes, places that are great for life to
Yes.
live today.
Yes.
Well, and actually, our friend Laura has a great story from the Gray Fossil site of some plant that was growing in the sediment, and she pulled it up by the roots,
Yep.
and the root came up and pulled up a taper bone
Yep.
with that it had grown through.
Yes.
Yeah.
Oh man, the number of mosasaur skulls with plant roots through them that I had to deal with in Kansas was really rude. But that makes the tropics today a difficult place to excavate, right? So,
Yeah.
like when I was on Rasinga, there were places on the island, in Kenya, there were places on the island where you could get these exposures. You had weathering, and so you could get to the rock. But if you have a tropical rainforest, you can't really excavate. So in
Mhm.
places like Colombia and so like in South America, the way that they are able to get to these fossil localities that are in these tropical regions is by working with mining companies or other sorts of
Mhm.
excavations, right? So
Yeah.
if you are excavating and doing a road cut, then suddenly you have this new exposure and the paleobotanists flock to it to try to get the fossils out as quickly as they can. But unless you are able to do these sorts of, large scale earth moving, that's not something that we can really get to because there are plants in the way of the bedrock.
Yeah. Well, and I've also heard it often mentioned that, like you said earlier, about forests also aren't a great place for fossils to be preserved because it's all about breaking, especially
Yes.
tropical forests. It
Yes.
breaks down stuff.
Yes.
So you can't preserve the leaf if I rot the leaf, but also it's breaking down soil and rock.
Right.
And if your soil is acidic,
Yes.
it could be breaking down fossils in real time.
Yes, exactly. Well, that's really part of the reason why the fossils on Rasinga were preserved was because of the volcanism, is because there was a volcano. And that led to it being covered very quickly.
Sealed in the goodness.
Yes, exactly. The soils there are also very calcite rich. So a lot of the fossils that I found, it's the strangest preservation I've ever seen. But I've talked to other people, and apparently it is not uncommon in the tropics, around the world. But the leaves were the organic material, the actual leaf was replaced with calcium carbonate.
Mm-hmm. Mm-hmm.
Yeah. So it
Ooh.
was so weird. So basically you have this calcite leaf.
Yeah.
And also the impression.
That's
So
awesome.
the part and counterpart. It was incredibly hard to photograph. I have since learned ways that we could have dealt with it, but because it was so shiny, you
Mhm,
couldn't
mhm.
really see anything, and it was the thickness of a leaf.
Right.
So it wasn't very robust. Oh, it was wild.
All right, let's go. Now that we've sort of laid the foundation for our fossil discussion, let's go all the way back. Because, as is the case with any living thing, there was a time in Earth history before there were forests.
Mhm.
So, Allie, if you would please describe to us what were the first forests like?
One tree.
Well, that tree is a bold statement. So, the oldest forest, the current record holder for the oldest forests, is approximately 386 million years old, roughly
Okay.
Middle Devonian, from Devon, England.
Oh, hey, where the Devonian got its name.
Yeah. So Somerset, Devon area. I got a chuckle out of that. And so this is a forest, I'm using big old air quotes here, that had a lot of calamophyton, which is Pledoxylopsid, which is basically a type of fern friend. It's a pteridophyte. So very but like in that umbrella group. Question mark? They're really
Sure.
old, so But importantly, couple important parts. They keep so in all of like the news like press releases about this kept describing it as palm like, and I feel like that is a stretch. Like
Okay.
it's because there's not really anything that looks like them. So it's like, I don't know, a palm question mark? I think they look more like truffula trees from the Lorax. But importantly, they lacked leaves.
Because
Oh,
they had all that floof.
So they had basically these little like bristles, kind of these little projections
Huh.
from their branches and nations, but they're not leaves. And so you're not really getting shade.
yeah. I was gonna say I don't listen. I'm no botanist, but I feel like if there's no leaves, I don't know if I'd call it a tree.
Okay. Oh, and also, you know how tall they were? They were 2 to 4 meters tall.
All right, listen.
So 6.5 feet to 13 feet tall.
That's adorable.
Yeah, this little tiny Brillo pad tree.
Right. I know people taller than that.
Yes, in that range.
Yeah, right?
I know 2 paleobotanists that are
Yes!
as tall as that tree.
Right. Yes. They would have been taller than some of these trees, right? Okay. So I am calling this more of a proto-forest.
Sure.
Mhm,
Like
mhm.
this is very you tried, and I appreciate it because without these trendsetters, we would not have gotten like eventual trees, eventual forests. So, you maybe David, are you familiar with the Gilboa forest?
Yes.
It's in New
It
York.
Sounds familiar. Okay.
Yes. So, this was previously called the world's oldest forest.
Okay.
Mm.
I would argue that like we're getting warmer here. So it's around about the same time. And again, you have dominated by this Lepidopsilopid, which is again this pteridophyte, Wattesia. It was originally called Eospermatopterus, but since realized like, oh, as with many really old plants, oh, this is actually a part of this thing that we named like 100 years ago.
Sure.
This one,
Eospermatopoulos was the name that I used to try to get into Ba Sing Se. Oh no, I said the wrong one. It wasn't Ba Sing Se, it was the other one.
He was the one that helped them study Godzilla.
Oh, you're right. That's what I was thinking. No, you're right.
obviously.
The worm guy.
So this looks kind of like a tree fern, but again, you're not really. It's not really a tree. It's trying. It's getting closer, but not really a tree. And then in the late Devonian, this is when we get into forests because you can't really have a forest without for real trees. So this is where we have Archaeopteryx, not to be confused
Not
with,
the bird.
with Archaeopteryx.
Who also likely was found in a forest.
Oh,
Well, it's found in the water.
that's true. So Archaeopteryx is this ancient tree, and it is an actual tree. So this is a pro-gymnosperm, so looking like probably related to gymnosperms, and it had fronds. It had these fern-like leaves, actual honest to goodness leaves, and that is important. So, and they were also like 20 meters tall, getting to 66 feet tall. So this is tree shaped,
Yep.
tree sized. It is the first species known to cast shade.
Whoa. It was a real sassy plant.
Yeah, I was about to say, who against?
Throwing shade.
Also, I have to say it was Omashu. Omashu was the
Yes.
that was what it
Yep.
was. I've been trying to remember it. You can tell we've been recording for 2 hours.
Yeah.
We're starting to go off the rails. I'm so
Yes.
sorry, Aly. The first tree to cast shade.
the first tree to throw shade. Yes. So because, and we talked before about the fact that light is such a determining factor in forests because it has this 3D structure. And also they had for real roots,
Ooh.
There you go.
which leads to soil formation.
Yeah.
So there's a lot of controversy with whether or not you can have true soil without roots. But here we go. We have actual roots, we have actual soil formation. These were deciduous. So you're dropping the leaves. This is leading to leaf litter, organic matter being incorporated into the soil. Like, this is where we have forests. The first forests, like, that I would very confidently call a forest is in the late Devonian. But even still, this is going to look nothing like any forest that we have today, because I'm very inconsistent with my definition of tree. I like to get into arguments in saying that you have to have secondary growth to be a tree,
Sure.
but in instances like this, I will use niche and ecological definitions of tree because I'm very confident that that did not have secondary growth, but I want it to be a tree, at least for this conversation.
Go to episode 73 to hear Aly go off about tree definitions.
I have strong feelings. But there has been a lot of variability and a lot of change through time in the types of forests that we have.
Yes, so we go back to the late Devonian into the Carboniferous, where we have our first actual forests. The birth of a new biome
Yes.
occurs during this time, and these would not have been flowering plants
Right.
because they did not exist yet. These would not have been the kind of gymnosperms that we're familiar with,
Correct.
even as we get a little bit later on. So over the history of Earth, the types of plants that are around have changed.
Mm-hmm.
The types of animals that are around have changed.
Mm-hmm.
The continents have moved around.
So much.
And the climate has continued to shift.
Correct.
So we in previous episodes we've done like trees through time, and we've talked about grass and stuff and other biomes through time. So just broadly speaking, how have forests changed over the history of the planet? Are there when did different types of forests show up at various times? Did different types of forests disappear at various times? Take us on a journey.
Oh, I had too much fun with this. This was so exciting. This is why I was going through the Ron Blakey maps and figuring out like where was the continent singular during this time.
Yes.
Singular. So as I mentioned, Middle Devonian, we have tropical proto forests, right?
Mhm.
Again, so we're in the tropics. We're looking at very different plants, and then we get into the late Devonian, again, tropical, first real forest, still having very different plants than we have today. So the Carboniferous, which is literally named because of, oh my goodness, all of this carbon, all this organic material from these coal swamps. So primarily from the majority of the Carboniferous, we are looking at tropical forests. And there is nothing like them today. These coal swamps, these rainforests, big ol' air quotes, there's nothing like them today. So these trees, again, kind of air quotes, were fire hoses. The amount of water that would go through these plants, they were incredibly inefficient because they didn't need to be because they were in a swamp. And so there was, right? So there was just, these were very, very wet environments. And during this time, right, you have animals who are on land. We have tetrapods. We have insects. So it's like, we're beginning to have, I wouldn't say recognizable, but like almost recognizable, right? There are animals on land. There are tree-sized trees. They don't look anything like we're accustomed to, but we're getting there. So these rainforests, eventually become fragmented with the climate change through the Carboniferous, and they eventually vanish, right? They eventually go away.
Would you say
And
they collapse?
I would say that the rainforest collapsed in the
Great.
Carboniferous.
Ah, she said it.
She said the thing.
She said the thing.
Episode 95.
Correct.
Yeah, that's what I said.
Y'all. So as we get through the Carboniferous and into the Permian really changed the trajectory of trees and of plants on Earth, because during the Permian is when we have these temperate forests with gymnosperms that are in these more arid regions. So we have these forests that are moving out of the tropics for the first time in a major way. So we have Pangea. So we have our supercontinent. It's arid and seasonal. And so we're beginning to have this shift into, honestly, more modern. We have modern groups, right? We have our ferns, we have our gymnosperms. Like, we're getting to the end of the Paleozoic and into something that's a little bit more recognizable. By the time we get into the Triassic and the Jurassic, now we're really getting into, like, this is looking more modern, because again, we're starting to get forests to both of the poles, these almost modern ecosystems with most major plant and animal groups present. We don't have flowering plants yet, but we're beginning to have most of the major players coming onto the stage. And there are both tropical and temperate forests. We don't have boreal, but we have tropical and temperate.
Nice.
And we don't have boreal forests because it wasn't cold enough.
Correct.
Like you just had polar temperate forests.
Correct. We went from pole to pole, but it wasn't cold enough for it to be boreal.
There was no northern tree line.
Correct. You just went
Weird.
around to the other side of the planet.
Yep.
Yes, exactly. By the time we get to the Cretaceous, right, we're getting into the end of the Mesozoic, we have the spread of angiosperms, and now we are getting into, like, if you took a time machine, depending on where you went, like, this might be recognizable. Might be, depending on where you went. So you're having these mixed forests. So when we talk about mixed forests, it is a mixture of broadleaf angiosperms and gymnosperms. And so you're moving from these gymnosperm dominated ecosystems into having more of a balanced mix between the two. This is also, in the Cretaceous, is also when we have the origin of the South American temperate forests, right? Because they're going to be from Gondwana and basically get stuck down there and are never really able to do any sort of mixing with North America. So when we get into the Paleogene, like, this is it. Everything up until this point, we're seeing these rise of these different types of forests, but they go away, right? So basically, anytime a new plant group comes in, right, we have the rise of the gymnosperms, and that's going to lead to a completely different composition and differences in many ways of how these forests work. And then once angiosperms come on the scene, again, we have this reorganization of who is in these ecosystems. So when we get to the Paleogene, this is the rise of the modern forests. So modern tropical rainforests do not exist until basically the beginning of the Paleogene. In the Paleocene is when, so modern tropical rainforests are only, like, 64, 65 million years old. The tropical rainforests of even the late Cretaceous are fundamentally different.
Yeah, it's very much in the same way that we like to blow people's minds by saying that dinosaurs, except for birds, never experienced grasslands.
Correct.
Well, dinosaurs, except for birds, also never experienced a proper tropical rainforest.
Correct. They definitely experienced something that we would call a tropical rainforest, for lack of a better term.
Yes.
Right.
But it is definitely not the same as what we have today. In addition to that, in the Paleogene, so the Paleogene is going to go from basically a 65, so from the KPG, right, from the mass extinction, to about 23 million years ago. So that about 40 million years. So we have the rise of the modern tropical rainforest. We also have these Arctic forests.
Yeah.
And they're not boreal forests. Like, these are rainforests, transitioning into mixed forests. But, like, honest to good, and there is nothing like that today. There was nothing like that before, and there's nothing like that now, because we don't have, for the time being, ice-free Arctic. And that is something fundamentally different than anything we have on Earth today, because you have relatively high temperatures, but also periods of darkness.
Yeah, and we've mentioned this in various times on the podcast in the
Yes.
past. This is a type of forest that does not exist today.
Right.
Yeah, that's
Where-
impossible today.
It is
Yes.
impossible today, and it was only possible for this narrow space of time in Earth history
Right.
where you had all the modern plants that you need, right? You've
Correct.
got angiosperm trees and all that. You also had warm enough temperatures that the poles were ice-free.
Correct.
So that means you had a forest that I guess would have functioned a lot like a temperate forest today, except that it got dark for like half the year.
Or like a tropical seasonal forest, depending on how warm it would get, and the seasonality is just darkness.
Yep.
Yeah. How do we know anything really about how polar forests would have operated?
I know multiple people who have studied them, and it's something that I don't understand well. But I got a guy on the inside. I should talk to my friend. Because I am very curious about it, because I also don't know how. I'm not even sure how we would find out how they work. I'm sure
Yeah.
smart people have really smart ideas about, like, I don't know, chemical signatures. That's, geochemistry is always how you do cool things. But I don't even begin to know where you would look, how you would, I'm guessing, like, maybe leaf mass per area would let you get into, is it evergreen versus deciduous? That could be one way of getting into it. But that's only going to tell you so much. Yeah, this reminds me, I need to talk to my friend Christopher, ask him some questions about the Eocene Arctic.
Yeah, because I would imagine you would have that sort of, you'd have a fall,
Yes.
right? It would make sense because, like you said, here, even where we live
Mm-hmm.
in the temperate zone, trees deal with a period of cold and darkness,
Yes.
right? That is what, it's not that cold or that dark, but it is a time where
Yes.
they have to just sort of shut down. So I maybe you would have just had a forest that only exists for a certain number of months, or also your animals are going to be doing wacky stuff where
Yeah.
they have to deal with it, and that's going to affect the productivity of the forest. It's a very interesting thing to try to wrap your head around.
Yeah. That's one of the things that, like, all right, I only get so many trips in this
Yeah,
time
this time machine.
I kind of want to go to the Arctic.
Well, and I guess we should specify this isn't like a hypothetical thing. We have
No.
forests
Yes. Yeah.
from
Yes.
the
I have
poles.
friends who have gone up into the
Yes.
Arctic and excavated. Like, this is something we actually know a lot about this. And we also know from Antarctica too. Like, I also have friends who've gone to Antarctica to excavate fossils and do that, because, like, we know that, there was a time when it was warm and you didn't just have an archipelago down there, that there were trees, there were animals that were living also in the Antarctic.
Yeah. Oh, well, and I think there was a news that we talked about not too long ago that was looking at it was a fossil forest ecosystem in it was Australia or New
Mhm.
Zealand, somewhere down south that the authors were finding was highly similar to similarly aged forest deposits in South America and
Mm.
suggesting that this seems like there was a continuous southern forest biome in a similar way that we have a continuous northern forest biome today. But
I
this was
love
during like
that.
the Eocene, so it would have
Yeah.
been a
Mhm.
warm
Yeah.
polar forest.
Yeah. Oh, I love that for them. And then finally, we get into the Neogene and into the Pleistocene. So this is where we switch from a hot house into an ice house, right? So we are not we do not have ice-free poles anymore. And so now we have this really we're getting into a more strict gradient. And this is when the tropics get confined to the tropics.
Yeah.
Because that's one of the things that, like, oh, we call it the tropics because today in our modern planet, that is where the tropical zone is limited. But that is just because today that is where the tropical zone is limited.
Yep.
That was not necessarily true in the past, but because of this latitudinal gradient that we have, because we have the ice at the poles, that's why we're limited in the way that we are. So the tropical rainforests are confined to the tropics. We also have, as I mentioned before, these pan-boreal, so basically going across the northern hemisphere, temperate deciduous forests.
Hmm.
So this is how we get these connections all around the globe. And specifically, that's why there are these similarities between Eastern North America and East Asia. So that's pretty much it. Um, it's
Every
really
forest.
every forest.
That's all the forests.
It is really interesting because in my head, the assuming the youngest forest is the rainforest, but that's because I forgot that the boreal forest had to wait for there to be a boreal.
Yes. Yep.
Yeah, that same. I also think about rainforests
Great,
are
that's the
that's a
last
new
one.
thing.
Yes,
But yeah, there wasn't boreal
right.
Mhm.
until we got cold.
Yes. Which is really interesting, right? Because, we have this, as we talked about, this very short lived Arctic tropical rainforest to these mixed forests and then into this boreal forest. So it is really these high latitude regions that have had, I think, the most interesting history of forests because
Yeah.
like the tropics have been tropical rainforesting as long as we've had somebody we could sort of kind of call a tree.
Yep.
And that makes sense, from the way that life works on Earth. Of course, this is a great place to be a tree in the tropics, but it is the temperate regions, and even more so once we have these high latitude regions, that we have this again more interesting story, these things that are popping up briefly and then changing. The high latitude regions have really been in flux for the last 70 million years.
Yeah.
Yeah. Well, and it's interesting to note because in case anyone out there is wondering, right now isn't the only time the Earth has been icy. Right, there was a major glaciation at the end of the Ordovician period, and
Mhm.
before that, there were the Cryogenian. But there were no trees at those
Correct.
times.
It-
There were no
and
forests back at that time.
very important thing to remember. No trees then.
We are living in the only major time period in Earth history where there has been both ice at the poles and trees.
Yes.
Yeah.
Yes.
Amazing. So obviously we've got new types of forests, we've got extinct types of forests. What are the ways, in addition to like the boreal stuff we've been talking about, what are the ways that modern forests are unique in throughout Earth history?
So this is kind of a sassy answer, but it's angiosperms.
Sure.
That's the difference. So throughout time, who has been the dominant player has obviously changed, but angiosperms have really done a good job, but they haven't
Mhm.
completely cornered the market because the gymnosperms have got the boreal forest on lock.
Yeah, we talked about that actually in the gymnosperms episode
Yes.
155, about how flowering plants have taken over the world.
Yes.
Yup.
except that gymnosperms have held on in one of the more extreme regions where they're like, yeah, up here where it's super cold and it's 30% of the forest space.
Yes.
That's
yeah.
this is our
Yeah.
territory.
Dibs. We call dibs.
Mhm.
But it is interesting though that in the worst, most inhospitable, worst is rude. I'm so sorry, Siberia. You're doing great. But the hardest to live in,
Especially if you're a tree.
if you're a tree, like specifically, the hardest places for a tree to be in the boreal region, that's where the angiosperms are like, yeah, but I'm deciduous. And also the tamarack, like the tamarack too. And I just find that really interesting. But yeah, it is. And so that's the thing that makes a modern forest is this domination of angiosperms, which the thing about angiosperms is they're close relationships with animals, right?
Mhm.
As dispersers, as pollinators, because, ferns don't need that,
Right.
right? And gymnosperms don't really either. And so it is that relationship with animals that is so different between the angiosperms and the gymnosperms, but also their tubes, and angiosperms are more efficient tubes than gymnosperms are.
They've got the best tubes.
They got the best tubes.
We have the tubes. Would you here's a fun little thought.
Yeah.
Would you say that boreal forests have a similar history in terms of their extent and existence as grasslands? Since they both kind of thrived and existed as the earth has cooled in the last 30 million years or so?
Yes. The timing is very similar between the two of them.
Hmm.
The rise of and spread of grasslands is not just a Miocene thing,
Right.
even though that's kind of the story we tell, but it is this this trend towards ice house, right? So having these more intense latitudinal gradients, and specifically with the case of grasslands is having those dry continental interiors. So
Sure.
but yes, it is an adaptation to way less hospitable environments. So there are definite similarities, right? So you have the gymnosperms who are the I've been through this before, I will do it again. And the angiosperms that are developing entirely new ways of photosynthesizing in order to deal with these environments. So yeah, I do see a lot of similarities, also because I think they're both underappreciated, right? Like boreal forests are not getting the love and attention that they deserve, and grasslands are seen as boring. I mean, my book called the boreal forest monotonous, right?
Right.
Like I think that both of them are more interesting than that.
Also, boreal forests and grasslands both house some of the best megafauna.
That is
Yes.
so true.
They got the big hoofed animals. They've got the largest animals on the planet.
This is true. And when I was looking into, boreal forests specifically, Pleistocene Park kept coming up,
Sure.
Yeah.
which is an attempt at Mammoth Steppe in a boreal forest. So, like, yeah, let's have grasslands in in our boreal forest. Obviously,
You got grasslands in my boreal forest.
that's exactly what I was
Mhm.
thinking.
Allie, this was super fun.
I had
I'm
so much fun.
I really do enjoy discussing biomes.
Oh, me
Mhm.
I
too.
think
They're
that-
that's why it's my
Yeah.
favorite textbook.
So episode 115 was with Allie, where it was a whole biomes episode.
Yes.
We talked about grasslands a bunch in episode 38 when we talked about
Yep.
grass. We have also did a biomes episode 128, which was the deep sea.
Yes.
No trees.
No trees. It's a treeless
Trees.
habitat. Just talking about habitats and environments and biomes is so much fun because it's such a all-encompassing topic. You
Mhm.
touch on all aspects of ecosystem. It's very, very cool. So
I like it because, and the reason I brought up biomes as an option before was it is context, right? Like it is the context that, the animals, the plants, whatever are living in, but also, it's something to point to. when I say tropical rainforest, this is what I mean.
Yes.
Yes, exactly. Fantastic. Hey, before we wrap this all up, we have one more thing to do, and that's a patron question. We got a plant one from Damon, who is a patron, as many of our patrons are. At a certain level, you can submit questions for us to answer here on the podcast. Damon asks, when were there any major plant extinctions? Were there others besides the Carboniferous rainforest collapse? So, quick aside for those of you who may not remember, episode 95, Carboniferous Rainforest Collapse, was a bad time for plants at the end of the Carboniferous period.
Yes, that is true. So, all right, to answer the question, I will give you a bad answer and then I'll give you a better answer. So, the bad answer is, were there any major plant extinctions? Yes and no.
Great. Thank you so
Yep.
much, Damon, for submitting that question.
So normally when we talk about mass extinctions, we are talking about it in a way that makes sense for animals. And so mass extinctions in particular are talking about the loss of major groups. So not just species going extinct, but, families, genera, families, even orders. So these much bigger, broader categories. And if you are looking at it that way, right? Like are families or orders going extinct for plants? The answer is no.
Mhm.
Like they just that's just not the case. And it's pretty consistently not been the case through all of the major mass extinctions, which has led to some paleobotanists saying that plants have never experienced a mass extinction, which I do not think is correct. But there was a paper that came out fairly recently looking at the KPG, looking at these extinctions and how in places you're losing 50% of species. And so even if you're not having entire families go extinct, bad things are happening.
Right. It's a bad time to be a plant.
It is a bad time to be a plant. And so it is really, like, if you go into the literature, you will find no evidence of plant mass extinction at the Permian. And it's something that we're arguing about. And I think it is basically a definitional problem that plants are trying to use definitions made for animals and they don't fit us. So if you are, strictly speaking, looking at the animal definition of mass extinctions, I mean, not really. They pretty much have not. But in terms of, like, have bad things happened to plants at these times? Would bad things happen to animals? The answer is yes.
Yeah. To quote one of my favorite podcast hosts, plants are not animals.
Plants are not animals! And they're full of tubes.
They're full of tubes.
It makes sense why they've never faced an animal mass extinction.
Yes!
Yep.
That's what I'm saying.
Damon, thank you for that question. Thank you to all of our patrons for supporting and submitting questions when you do. This has been a very fun episode. Don't forget to check out the blog post that will be up on our website about this episode. We'll find pictures of forests. That'll be pretty fun. I bet there's a bunch of cool pictures of forests out there.
I'm so excited.
I've got some pictures of forests that I was just thinking for like a teaser image. I can grab a picture that I have or that you have.
Oh yes.
Because I took some pictures of I was in Cottonwood when I was in Alberta. It was in Dinosaur Provincial Park. They were talking about how they have one of the only major remaining cottonwood forests.
I love
areas,
that.
I think
I love that.
Cool.
I love that so much. I love cottonwoods.
So check out the blog post, links, pictures, and all that stuff. Thank you to everybody who requested this episode. Thank you to everybody who supports us on Patreon. Thank you to everybody who just listens, because we really appreciate that. Extra special thanks to our top tier patrons, Sarah May, Bugs All the Way Down, and Danielle Loves Bugs. We extra super appreciate your top tier contributions. Don't forget, go listen to Leave It to Us. By the time this episode comes out, Leave It to Us will be nearing the end of season 1, but Aly and Nora will be doing a mailbag episode. Patrons who support Leave It to Us on Patreon can submit questions for the mailbag. Also, this episode will be coming out the weekend that Will and I are at DragonCon.
Woo!
So, retroactive thank you to everybody who came and saw us and said hi to us at DragonCon.
This is probably the only plant content you will have gotten from us this weekend.
There are some plant panels planned for DragonCon for the Science Track, but we're not on them.
Nope. Yep.
Well, someday we'll have to bring Aly to DragonCon with us, and then you can talk about plants.
Oh, maybe I mentioned it in coconut milk.
Oh,
We'll
there
have
you
to
go. Fantastic. Yeah,
maybe.
Also, another thing that we probably announced at the top of this episode is Spooky is coming up. And this is in the past, but probably we announced the theme for this year's Spooky. And Aly, I can say the theme now and you'll know a month ahead of everybody else, or you can wait and hear. Amazing. Well, hey, Spooky's coming up in October. Tune in. If you want to know what the theme is, rewind back to the beginning of this episode when we probably said it.
Sounds good.
Aly, thank you as always for gracing us with your planty presence. It is always an absolute delight.
I'm so happy to be here. Thank you.
Yeah.
Let's make like a tree.
And form a forest.
And get out of here.
Bye.
Bye, everybody.
Bye.
Thanks for listening to the Common Descent podcast. You can follow us on Facebook, Twitter, YouTube, and check our WordPress blog for pictures and links after each episode. Huge thanks to our patrons whose support helps keep this podcast running and who get access to bonus goodies on Patreon. The song you're hearing is called On the Origin of Species by Protodome, which we found at ocremix.org. Thanks again for listening. We hope you'll join us next time.